To slop or not to slop? That is the question. I think I finally cracked it. For months, I've actually been running coding agents that have been working like most engineers do. You basically prompt, you wait, you review, and you sigh a little bit, and then reprompt again. And then with the advent of cloud agents and doing stuff on my phone or an OpenClaw, I do that process, but I'm still sitting down reviewing quite a bit. And I don't know about you, but my desktop repo has probably about like 30 different agent branches. And right now, I'm actually stuck on a giant PR. 193 commits are basically waiting to be merged into a branch. And I've actually just been genuinely scared to merge it because it actually touches security, database migrations, legacy production data, and all the API keys at once. And I don't know about you, but I've been trying every single thing that's out there, from loops to graphs to whatever you can find on the internet. And I don't think any of them really kind of solve the bigger problem to make really reliable software as repeatable as possible without spending billions and billions of tokens per month. And this is the real state of agentic engineering for pretty much a lot of us. And almost nobody really shows this on camera. So I'm excited today because I actually found someone at Microsoft who does research on this exact thing, has been building systems that deal with massive and large code bases. And they actually are doing agentic engineering at a level that I actually had no clue was being done. And the craziest part right now is that this is actually open source. And I'm so excited to bring to you on the screen Alex Lavaee. Welcome, Alex. I'm super excited because I met him at the AI Engineer in San Francisco, and he came up to me and says, "Hey, Ray, like I'm working on something that you should probably check out because, you know, I know you like to ship software and stuff on stream. It's not, you know, little kiddie stuff. It's actually like really, really real things." And Alex, tell us a little bit about your background.
Yeah, thanks for having me on, Ray. Hi, everyone. I'm Alex, and I'm currently at Microsoft Research, and I work in the agentic engineering space and dev tools. And prior to that, I was in the Windows team at Microsoft, working on building internal coding agents for Windows developers. So Windows is a billion plus lines of code, so scaling coding agents to that size requires a lot more engineering, and it turns out that the typical coding agents don't scale at all for that size of a code base. And I've seen even past tens of thousands of lines, these systems start to fail. And prior to that, I have a applied research background and research background, also engineering background across the industry at Boeing and also biotechnology and companies like Edwards Life Sciences. And I also have 3D and 4D computer vision in terms of my research, but now I focus a lot on software.
That's super incredible. And today we're going to be going through basically what we call a masterclass. And I've gone through progression with Alex privately a couple days ago, earlier this week. And I was telling you all these problems I was having with all these repos trying to merge. And Alex is like, yeah, well, there's this thing called Atomic. And with Atomic, you can, and this is something that basically Alex has made. And we're going to be checking this out on stream. And so you may have been hearing these terms called loops and graphs and all this stuff. And the good thing is that you don't have to like figure out how to do a lot of that type of stuff per se. And if you're an engineer, maybe working on a lot of code, and if you've probably been doing a lot of prompting, I feel like this is probably for you. If you're just getting started with prompting or software development lifecycle, or maybe haven't had a background as an engineer, you can probably still learn a lot from this live stream. It's going to go fairly deep pretty quickly in some areas, but I invite you to ask some more questions. This is our live stream for all of us to hang out together. And we're hoping that we can go through so that even other people who've had fringes of experience can then take at least their software development lifecycle stuff into the next level, no matter what level you are, whether you're an entry-level engineer or you're already pretty fairly experienced. And having Alex on the stream is going to be quite the gem as far as a process. And one of the first things that we did was to take a look at my code repo. And I sort of vague posted this the day that it came out, like the day that I was working with Alex at night. And one of my problems is that I have GPT 5.6 as a subscription, but I pretty much, if I want to get work done, I have to rely on the higher versions of Soul and these other models. And I've heard other people on Twitter talk about, oh, I use Luna at max mode, or I use Terra, or I do this. And it's such a pain for me to just manually assign each specific thing to either a skill file or to a specific task or for review. And like doing this over and over across like many repos also gets extremely exhausting. And sometimes I don't really know if that's actually the right thing for that specific task at that time. And I think I started to understand it's like, I don't have a skills problem. I don't have a loops problem. I don't really have a workflow problem. I have more of like an agentic runtime problem. When these agents are running, us as engineers have to prompt them or put the scaffolding in place so that the agents can make the right decisions when they're executing their tasks. And so insert Alex here. Tell us more about agentic runtimes, what you've been working on. Tell us a little bit more about Atomic and how we've kind of came to this process. And we're going to, through this live stream, we're going to see me actually start to use this. And we're going to show you some of the basics that you'll need to get started. So stay tuned. If you're going to be watching this also as a live stream, later on, it's going to be a video on demand. So you can come back to this exact link and there will be timestamps that will take us through this. I'm also planning to have an edited version. So after this live stream, I'll cut down all the different pieces and put together like a larger piece for all of us to kind of come back. Because I know not everyone has time. People are kind of coming and going throughout the stream. So if you can, drop a question and then we'll have a question and answers throughout, and I'll just be pulling stuff in as it's relevant. So yeah, Alex, let's go ahead and take it away.
Awesome. Sounds good. I'm going to start with describing what this agent control plane is and what a runtime is and how it fits into loop engineering or graph engineering. But my objective from this is to demystify hype and focus on what's actually practical and what can scale to production from the billions of tokens that I've spent. And so as Ray was mentioning, I'm currently at Microsoft Research and I work on agentic engineering. Before that, I built internal developer tools for Windows engineers and worked across applied AI and research teams across the industry. And in my spare time, I like to work on open source projects. Today, I'll be discussing loops and then graphs, then workflows, and what verification is and what context engineering, durability, and where human judgment belongs in all of this. Then I'll show you how to build these systems. So we'll go through these practical examples, and I'll then show you more about what Atomic is about. Just a brief intro to what Atomic is. It's a verifiable coding agent runtime. And here I define a runtime as an environment that your agents can execute in. Just like you have Node or Bun for JavaScript, Atomic is, I consider the runtime for agent work. So it owns things like sessions, tools, models, and state. And it also has this workflow runtime, which is a graph-based system that handles durability, resuming, and rate limit handling and fallback models, just to be as fault tolerant as possible for multi-hour, multi-day, or even multi-week sessions. And here, verifiable means that every claim is inspectable by you as the engineer. And this evidence includes outputs, test results, artifacts, checkpoints. It's not the model saying what it's saying that it's done. Maybe you've seen that a lot. It's actually some proof of completion, and otherwise it didn't happen. And what verifiable, a property of Atomic is it's a verifiable runtime where correctness is a property of the system, not something you rely on the model for. So we add all these deterministic gates that we'll get into and apply real engineering practices to when working with coding agents. So it's kind of like you're applying CI level trust to agent execution. And Atomic started as this open source project because coding agents handle long tasks well, but fall short in these real engineering tasks I found. And I wanted to build a community of engineers who deeply care about the quality of software. And you're seeing all these regressions getting shipped. And I wanted to have this control plane that engineers can own and the process that checks the evidence or verification capability. That's all was incredibly important. So that's enough rambling, or about like what the background is, and I'm actually going to get into some cool theory. So I want to relate agentic engineering and loop engineering and graph engineering to existing analogies that we might already be familiar with. And one of them is control theory. So control theory, if you go back from a theoretical computer science standpoint, is when a system varies, reliability comes from comparing what happened with what you wanted and then correcting the next move. So here loops in the framing of control theory is that engineering isn't a one-shot prompt. It involves a multi-stage machine that is implementation, checking, fixing, and repeating until CI is green, and end-to-end testing, and uh, integration tests and unit tests, etc. And loops make that cycle executable through bounded tracked iterations with explicit stop conditions. So keep going until the test passes becomes a way to construct the system and programmatically. So if we look at the diagram from left to right, we have these ideas from control theory. The acceptance criteria here is the set point, or it's like a desired state. So we want all test cases to pass. We are looking for all user satisfaction, things that you can measure. And the workflow policy here is the controller. And I'll explain more in depth what a workflow policy means here, but it's like a way to define a graph of what happens in the execution of the model. So and then there's the actuator, the agent and its tools are the actuator. You can think of this as what everyone is talking about with the harness. And this is what actually makes the change. So you have specific tools for the code base. And then there's this idea of the plant in control theory. That's the code base in software engineering. And test types, lint, and independent things are independent review are sensors. So the sensor compares the code base against acceptance criteria that you define and returns a feedback or error to the controller. So there's this feedback loop that continues, and hence the name, the loop engineering. But you can really frame it as just a workflow. And so you have this pass, repair, fail, or stop when the budget ends. And you have all sorts of ways to determine the execution mechanism and what the completion criteria is. And this is what I want to emphasize. The output varies, but the control stays explicit. So you have you have this sound control of passing and then repairing and then failing and then budget ended. And these are all status indicators that can get sent back to the engineer, and they can inspect what happened with this a long run, a multi-hour or multi-date run. Oftentimes you have these long runs and you have no idea what happened. You have no way to audit what happened, and you have to spend hours oftentimes just probing the model to understand. And this control loop framing is not original to me. It was inspired by Dex Horthy and the human layer team. And but I'm mapping a new take, which is this verifiable agent runtime. So that's an idea I want to introduce throughout this discussion that we have and through the demos we do. So a control loop tells us how work responds to feedback, but once work spans many tasks and checks, like real engineering tasks do, the transcript can't tell us what depends on what or what can start next. For that, we need a graph. So let's explain why graphs are important. On the left is what most agent tooling hands you. You have a transcript and you have a series of requests and responses, and these are structured objects like tool calls and thinking blocks. And then the agent eventually says, okay, I think I finished this stuff, but it's just relying on its internal thinking trace or its internal process. But what a loop is and what a graph is there's a transcript that records the work, but a graph coordinates the work. So the definition of graph here is the shape of a run. So stages or sessions are nodes, and handoffs are edges, and the whole structure is a DAG for the work that the agents do, directed acyclic graph. You can also create cycles in the graphs, but that's more complex behavior. I like to frame it as you have this certain execution order. And it's a live inspectable record of what is happening. And graph engineering then takes that concept, and just like how we had prompt engineering, how we optimized how we work with one model or agent, graph engineering, I like to frame it as it it structures around many agents and models, and it coordinates at the system level. So which stages run in parallel, where verification gates sit, what evidence flows between them, and when a loop stops. And reliability comes from this topology. So the four cells on the right are the questions a graph answers. The first one is what depends on what. This is the dependency understanding. And then there's also readiness. How do you determine when you're completing the task, and whether it's blocked or done? Do you need to defer to the human? And so independent branches run in parallel, and then there's this evidence idea, and it stays attached to the work that produced it. So one failed branch is repaired without redoing the test. So the idea of evidence is you need to have some sort of transcript or idea or some artifact to review, and this makes it inspectable by an engineer. And then you have control, and this involves can you pause a node and then be able to resume, and can you steer the system, or can you steer the graph while it's working? And that's something to emphasize, where you can get a lot of power if you control the dynamic execution by steering to different subgraphs based off of certain things. Like if there's a regression in CI, you can go to a sub workflow that tries to do reproduction of that error, and then if it's reproducible, maybe you can add it to a GitHub issue, or use a linear ticket, and things like that. So
This is cool.
the
I
part
actually want to see
yeah,
if I can show them a little bit of an example. And we're going to get into like a live example too a little bit later on for those
yeah,
who are just tuning
for
in.
sure.
And this is kind of what it looks like in actually my workflow here. So I posted this on X, and people were like, "How do you actually generate this type of graph thing?" And it's like, I didn't actually create this. And so I think this is the other refreshing part as an engineer. It's like you can just instruct it to, or have the agent go discover this thing and have it, whatever your workflow process is. If you have certain things in your repo that follow certain conventions, it will find them and then try to figure itself out and fan out the work or work in this type of manner. So in my case, I was doing a massive review because of this large 130 commit plus feature that's going to be landing in with all these different implications, from databases to APIs to security and all these different checks. And so it did a security audit that ran for 30 minutes, a deployment plan. The deployment plan is really important for me because I have all these moving pieces. And then there's a migration audit as well. And then what's the user impact? That's the user testing, and any key lifecycle things that I may have missed. And so it actually found quite a bit of bugs. And you can see these can run for hours at a time at different times. And they can have these dependencies, which is kind of nice. And I didn't have to generate this. And so if you're kind of looking at where is this puck really going, is this for me? It's going to be really exciting. And once you kind of get your hands on it, it's going to be really good, cool. But I just wanted to kind of pop on in and just kind of give a quick, like, real example of what has actually happened using this process in my code base and so forth. Yeah.
Yeah, definitely. I think kind of workflow design will be an interesting problem to solve, and I think the evolution of the role that we have is figuring out how to engineer these systems in a way that they increase the reliability. Because I really like the way that Adi Osmani frames it, which is we have the judgment filter. So we decide what goes into production, and we're responsible for what goes to production. So that's kind of one of the most important points I want to take with everyone who's listening, where we have an obligation to have high quality in our work, even if it's accelerated. Doesn't mean that we should introduce Slop to a code base, or introduce more regressions. So I want to show how everything comes together, and with this idea of a loop and a workflow and a run materializing as a graph. So in this slide, I have some TypeScript code. This is actually the atomic syntax, and it defines a graph using the atomic SDK. And so there's a prompt that you pass, and then you can control the context with a fresh context window. You can even fork context windows. And there's also, if you want to pass output structured output, you can, and you can define a schema here. And then you can define parallel branches. So there's primitives for spawning parallel branches, and then you can control concurrency of those parallel branches, because realistically you want to prevent from getting rate limited. And there's also the ability to fail fast, right? Because these are real engineering workflows. You need to be able to control them at a granular level. So sometimes an error is okay, but sometimes it should halt the execution and should go back to the agent to delegate what happened. And that's a key part of building fault tolerant systems, really. And then this is really a common pattern. You can partition a work, and this is what Ray's waves does in terms of splitting into worker agents, and then they synthesize the work. So this is kind of a mini example of that. And you'll notice that it's like the runtime itself is a combination of Node and the agent runtime, where you're using primitives in JavaScript itself, like the await functionality, and this creates a barrier in the event loop. And so you're able to block execution until all the dependencies are constructed. So it's almost like an interpreter of sorts that's dynamically executing this graph. So this is how I would visualize it. So the key things here are you can await dependencies, you can create dependencies, you can bound concurrency, you can join tasks. I think this is all just standard things that we're used to as engineers, but just framed as this idea of a graph. So I think the most exciting part about the Atomic and its runtime is that verification is what turns this execution graph into a real feedback loop. So these 4 boxes are from the sensor slide, from slide 2, but they're made more concrete. And I want to introduce this idea of verifiable primitives, the building blocks that make trust structural and track stages, durable checkpoints, tool calls, artifacts, verification gates, structured outputs, human approval points. All of these come together. And you can compose these in the same way you compose functions, and each one produces evidence. So let's walk through the pipeline to make sure this is more concrete. So the first stage of verification is proposing. So the model writes a change, and we don't treat it as correct because the model says it's done. That's one of the most important concepts. And then we actually measure things. And Atomic runs real checks, or you can also replicate this through a deterministic tool call, because you don't need the agent to do everything. Sometimes you just need to run a unit test, and that determines whether the criteria is complete. And so test type checks, builds, browser flows, any command you can run. These don't have to be dynamic. These can be deterministic. And for UI and runtime work, the workflow can capture screenshots or short recordings that prove that the workflow actually ran. And this is a way to lighten the load when you're reviewing the code as well, because you can attach these artifacts to PRs and then have a complement to read for very large changes. So there's the second kind of check underneath as well, where TypeScript checks the declared contracts between stages at build time. This is specific to Atomic. So Atomic uses the typebox library, which is a popular library that validates structured results. If you're familiar with Python, it's like Pydantic. And it catches missing fields, wrong types, and undeclared outputs. So the workflows themselves are type annotated. And the shape checks only prove that the data looks right, not that the code works. So that's why it's important to I wanted to make sure that in the design of Atomic, it includes these executable checks, not just at runtime. So after that measure, you need to review what happened with that measure. Did the test case pass? Or you could even remove this review if you're confident in the measure, but usually you want a model that interprets that measure because that allows you to then pass to a decision stage. So in the review stage, what I like to frame it is that you have a fresh verifier, and this can be a language model, and this verifier reports from clean sessions that receive these files and evidence from the measure stage. So this could be an output of a test case, and this is then passed to the reviewer, and it determines, okay, what did the goal that you want to get achieved, and then this reviewer passes the feedback, and then there's ultimately a decider, and it's a model that proposes an outcome from these reports under a bounded repair and review cap. And so this itself is like a sub loop that you can run depending on how much assurance you want. It's almost like you're scaling like how much you're checking the code. If you want higher assurance, then maybe you run this review loop for hours or days because it's a critical thing that can't fail when it goes into production. And The way I frame it is you can skip a full manual code review, uh, only when the checks are comparatively cheap, objective, and hard to spoof. But I still think that people should be. I can't believe this is a hot take, but people should still be reviewing the code that they ship to production. But we need to frame it in a way that it's easier to review that code. And if there are critical code paths, that those should be emphasized. If you were to, I don't recommend this. If you were to skimp on review, I would say uh, create these systems that can provide you evidence that the behavior is working, and then focus on critical code paths. So reliable verification depends on something we haven't discussed yet, and that's what each stage knows and what we deliberately keep out of it. So this is where we're going to talk about context engineering and how it plays in. Oh, and I
This
forgot
is
to mention that,
awesome.
yeah, human judgment, reviewing the code, or like reviewing a subset of the code that's incredibly important, is still one of the most important things that you can have. And it's not just for verification, and I think it's also for participation. So as we work with these systems, we gain an understanding of like the problem that we're solving, and in turn creates new ideas. So I don't think humans will always be the verifiers, but they will always be the participants in the system, and that
This is
leads to
great.
innovation. Yeah.
Wow. Yeah, let's just get a moment real quick since we're live to get a couple
Mhm.
questions through. I know people may have some
Yeah.
questions and so forth. And if you're just landing on this is basically Alex Lavaee, and he's a researcher at Microsoft, and I think you're a staff level researcher, and he's been working on
Oh no, I'm
building.
actually, yeah,
What's up?
I recently started, so I'm a junior
Oh,
engineer.
junior, okay. But
Yeah.
has been the work that he's done with this repo called Atomic has impacted many engineers all across, from like staff level engineers all the way down to people who are doing junior engineer level engineering work, uh, to better understand bigger code bases and to not introduce slop. And so a lot of people have been talking about graphs, loops, and all these different things. And we thought it would be a good idea to do this little masterclass session so that we would capture a lot of that information, kind of distill like some of the myths and demystify some of those things. Because there's a lot of talk about it, but there aren't really good resources online that kind of explain how you then tie that together with everything that's now happening in agentic engineering. And so what's nice about this live stream is that you can go back with timestamps. I'm going to have them after the stream and kind of rewatch some of those segments. I'm also planning to cut up to the live stream so you can have some of that later on. And so what's really amazing is that, yes, Nor Lava, this is the most cracked junior engineer. Yeah, exactly. You're quickly coming up. This is like my favorite part. It's like doing stuff live. You can ask questions right now because we've covered a lot of stuff. And yes, people don't actually review their code sometimes now. We just kind of ship and keep going. But we're trying to change that. And I think people are recognizing that maybe they're a little bit more fatigued at the output or the quality, and we want to try to improve those things. So I myself, as an engineer, have been saying, okay, I'm building my own skill files. I feel like every senior engineer, or just not every engineer who's taking their code seriously, who takes their product seriously, realizes at some point they said, I have to build my own skill files. I have to build my own workflows. I have to build my own like worktree system, my own cloud verifier, like whatever we do. And we're all kind of sort of duplicating everyone's work. And then 3 months later, the models come out, and then skill files are somewhat irrelevant now because now they can just figure it out just by a couple lines of text or something like that. And then we're kind of now back to this square one again. It's like, what is the problem that we now have? And is it now a control flow problem, right? So are there problems that are control flow based? Are there not? At the end of the day, what Alex is basically saying, that verifying is still kind of the moat of it all, really, because if you kind of know what you need to verify, then it's easier to direct a lot of the energy, your tokens, your budgets, in a direction that's actually going to pay off, whether it's customer satisfaction, quality of products, and so forth. I've worked on devices. If you've ever used one of these little things, or whatever product here, it's now in the hands of billions of people, and people update those devices, and they're not afraid to update them as a result of not only myself, but many engineers who put so much blood, sweat, and tears before AI agents. And a lot of that stuff, you have to really think through a lot of every single scenario, from what happens at the factory, from unboxing it to, whatever it ends up in people's hands. And so that level of thinking and attention to detail is something that does not get missed, but then is very repeatable, very measurable, and very like much things now that if you have agents to do it, it's like, why wouldn't I hire robots to do that while I'm sleeping and then wake up to get some results and see what I need to do next, or whether an intelligent system needs to hand that over and take that off. So that's kind of where we're headed with this. And I feel like this is kind of a really good time to discuss all these things. And so, yeah, I want to definitely get some questions. I think somebody had a question. Obviously, Jay says, thanks so much for having the masterclass. Jay also says, thanks for like the knowledge and so forth. And Fooled by Primes talked a little bit about this, but basically saying, is verifiability implementation using cryptographically secure history, maybe combining bipart with graphite or graph with Merkle tree, or I guess kind of more of like a technical implementation? I know the code is currently open source and that folks can take a look at it, but I guess you had a question on that.
Yeah, that's a great question. I would frame it as verifiability is what the criteria that you define for the completion of a task, and that can be like doing an audit of even the files that an agent has edited, so you can check that it doesn't try to be deceptive, or it edits files that isn't supposed to, or like quote unquote reward hacks. Like that's things that you can verify. It's framed around like those types of things, and also end-to-end testing with Playwright CLI. So imagine recording a video of proof for a front-end change, or using tmux automation to drive your CLI and fuzz test it. So it involves a combination of these approaches. And what Atomic, the library that I'm working on, just provides those primitives to make it easier to verify. But you can add components like cryptographic audit trails, and you can. There are some cool projects that allow you to essentially sandbox your environment and even ensure that it doesn't edit files that it's not supposed to. And that's where sandboxing is really important.
Very, very, very cool. Thanks for the reminder to leave a like. Ladies and gentlemen, if you haven't had a chance to, smash that like button, because that's what we're getting this out to more people. And what's nice about it is if you like this thing, that it tells the algorithm that there's probably other people like you who are kind of in a similar boat, and it just gets them out there faster. So helping me help you is really awesome. I like this project. I'm using vision models for a project like RF, DETR, and SAM3. Can those be used with this environment?
Yes, actually, it can, because Atomic has multiple model providers. So you could integrate a custom model, so you can load a vision transformer. I have a computer vision background, so you can definitely do that. And I would recommend maybe looking into, like, it might be a little bit of upfront work. Like for example, there's Llama CPP, which is like based on GGML. But I have a Dino V2 CPP project that uses GGML, and you could create an integrator. Atomic is a fork of Pi, so you can add a custom model provider and use that in your workflows that you define. So Atomic is a superset of Pi, and so it extends the functionality of Pi, and you can do things like define vision models, or you can even make an API call if you want to use hosted inference, because the workflows are just code, and so you can ask Atomic to write that sort of workflow for you.
And I was even able to use, I have Cursor
Oh
subscription,
yeah.
and I have Cursor Cloud Agents. And to me, my little Mac Mini, I had like 4 projects running at the same time, all doing crazy nodes and stuff. And I found out the bottleneck was me and my little Mac Mini with, the like 16 gigs of RAM. And so I thought, oh, why don't I just put them all in the cloud? I just literally just typed in, can you just use Cursor Cloud and go figure it out? It's already on your machine configured. And so then it's like, oh, yes, I can. And then it just converted everything. It's like, let me kill these work trees and move them over to the cloud. And then it just like goes way faster after that. And so whatever stuff you have installed in your system, you just have to prompt it. And it's just one type of thing. So we're going to do some demos a little bit later. I just wanted to kind of stop in because it's a live stream. This is really special to have Alex live on stream, and we can ask questions live. And that's kind of, one of our secret sauces here for doing things. Sol 5.6 won't generate review testimonial style copy. Is this a fixed limitation, or is there a supported way around it?
Generate review testimonial style. Can you clarify?
Yeah, would love to. Yeah, let's get some clarification. I keep getting random posts about graphs. I just don't trust the sources, but it seems to be a trending topic right now. It's why we created
Yeah,
this. Yeah, right.
yeah, that's a very fair point, and I think a lot of the AI engineering stuff is hype, and it's trying to maybe drive a vague narrative about how you should approach solving problems. But I more so think about it like how can you relate it to fundamental things that have always existed in computer science, which is why I framed like what workflows are as really control theory. So you don't have to adopt graphs for everything. But more so, the moral of the story is like you need to be principled about how you use these systems, and getting the best results out of these systems involves exploring them and exploring things like graphs. And I like to separate atomic from graph engineering because I don't treat it as really graph engineering. I treat it as like building reliable software. So, however, you need the primitives to build reliable software, whether it be graphs or having some way to have accountability for the model, I think that's important. So, the verifiable runtime is like what is the most important part of Atomic. It's not that it's a graph engine; it's that you can have artifacts as an engineer to review, and Atomic just tries to give you the primitives to make that easier. So, I'd recommend, yeah, definitely if you're interested, dig into Atomic and see if it works for your use case. But it's not like I don't want to drive a hype train that, oh, this is AGI, because it's not. The system requires real engineering, but if you have that ambition or and take that learning curve, I think you can get pretty good results in production with something like this.
Yeah. So like this is the repo. I'm gonna put the repo into the chat if you haven't had a chance to go play around with it, because we're gonna start to get a little bit more into the masterclass here as we talk a little bit deeper of like, what is this control stuff? What is an agentic runtime? I've heard these types of words in my live streams before. You may have seen me bring on a couple folks from Korea who went absolutely insane, and what they did was they were able to make a whole like clone of Claude code in basically 2 hours on a plane using their phone. And the techniques that they were using, require these types of things that will actually run. The agents are making decisions. They're spawning out new agents. They're doing things. And the fact that they're on a plane texting, you don't have a lot of internet. You can't run all the code and stuff on your laptop. You have to run them in these other systems and other places. And then decisions need to be made and all these things need to happen. So I'm really excited to just continue the conversation here. Yeah, this is a nice little masterclass. Take some time. Because it's a live stream, like I said, you're going to be able to go back later when this turns into a video demand with chapters. I will have some of the stuff edited, so be on the lookout for that this weekend and next week for this stuff to be cut out, because we need more people to like start talking more about this stuff and sharing publicly, instead of just saying, our graphs, like, dude, I've been doing graphs, and then like not even show us what that means for them, their organization. But the bigger question really for me, it's like, as an engineer, what are you doing with this? Are you actually generating higher quality results? I don't know about you, but I've been trying some of these stuff like from these companies that claim that they're doing this stuff, and like their qualities keeps getting lower, or they don't have the right gates or the right tests or the right things that they should be verifying consistently. And I keep seeing regressions slip through, and no system is perfect. Even where I used to work at, there would be hiccups and things that happen. The bigger your user base, the bigger the errors the surface feels, even though it only affects 0.01% of your users. So if you have a billion people who use ChatGPT, 0.01% is a freaking high amount of people that will be affected, and that those people will scream really loud online. So I think with that, I think we should probably move on to context and handoffs and continue the conversation here, Alex.
Yeah, for sure. So this is the context engineering segment. So we basically, to give a recap of what we've done so far, we talked about this idea of control theory and loop engineering and how they're related and how theoretical computer science comes into play. And then we talked about this idea of graphs and how you can have dependency and durability. And now we're talking about kind of low-level primitives. Maybe we can think of this as sort of an operating system, but in a different context where uh, no pun intended, but where you have CPU threads are like subagents, and then you have memory, which is like the context that you're directly managing. So you can think, I like to think of context engineering as like manual memory management in the in AI engineering terms today. So what is context engineering, or like how do you think about passing context from different stages in a sub agent, or passing from session to session? And context management is deciding what each stage is allowed to see. And this becomes an optimization problem where you can't just hand every stage the whole repo, or every you have to think of everything as you could add noise, and it could cost more, and it could bias the next decision. So I think you have to be very principled with how you approach this type of problem. And let's compare two lanes: a fresh context window on the left hand side, and then a forked context window. And the idea of a fresh context window is you start with a clean model session, and this is uh, it sees only what you handed, and that's the prompt, the files. So you have the system prompt, the files, the evidence. That's what you want for review. So like a reviewer sub agent. Uh, I much prefer a reviewer sub agent to have a fresh context window, and I'll give you an explanation from a theoretical perspective. Let's say that you have a worker agent that does some task that you define, and then that generates the output of the task and claims that it's done. And then in the same exact thread, you say, check your work. If you think about how these models work, these models are autoregressive in nature, which means that the next token depends on the cumulative probability of the previous tokens. And if you're thinking about a reviewer agent, it's trying to maximize the probability that the previous tokens are aligned with this next output. So it's inherently a biased estimator that you're trying to have review your code or review some task. And this is why you creating a new context window, or even passing small artifacts between this worker and this reviewer, leads to, from a theoretical perspective, better results. There's evidence that explains this directly. So that's what I would use for reviewer. And a fork is when you want to continue from an earlier conversation. It keeps these decisions that were made or the next step still needs. You'll notice that a lot of the time when you have a worker agent, and the worker agent is like a great model for forking context, because it needs to know what it previously did. And so it can use that information and avoid rediscovering things that it already had seen. And this is to avoid wasting tokens, and also so that it can self-correct itself based off of a previous trace that it had. So concretely, the implementer or the worker agent can write a patch summary and test results to a file. And in your workflows, you can pass those files or those artifacts, as I was describing before, and the reviewer can read those artifacts, but it doesn't inherit the context window, preventing it from getting biased in any way. And so the findings go back into the implementer's fork, and then you continue this loop. And stages share work through explicit handoffs, like declared values, outputs, files, and reads, and you can think of them as the interface between stages. One trick I would highly recommend is, instead of thinking that you're passing tokens or context directly between stages, I would think of passing artifacts between stages. And the distinction here is passing tokens is directly loaded into the context window. But when you're passing artifacts, the model can search through context that it finds useful, and prevents overflowing the context window with irrelevant information. And so this is one of the principles in Atomic that's emphasized. So when Atomic creates workflows for you, it saves artifacts as files. So it's more context efficient and prevents the model from diverging because you're adding unnecessary context. And I think that's where a lot of people go wrong. Context is finite. And when a session nears its limit, Atomic drops these older, a session is finite, and you need to have some way of passing context so that you're as efficient as possible. And then another thing I wanted to mention is where compaction plays into this. So context is finite. So when a session nears its limit, Atomic drops selected older messages and protects recent ones. And Atomic uses a form of compaction called verbatim compaction, which is different than what other coding agents use or other runtimes use. Because verbatim compaction, instead of generating a summary of everything that was done until that context window overflow, it's it's selectively removing elements from the context window. And so instead of doing a lossy compression in the form of a summary, the model has access verbatim to previous message blocks, and it can use those to actually better guide its process. And there's a lot of research that actually shows that passing verbatim compaction significantly outperforms summary compaction. And that type of trick alone helps significantly in scaling these systems to multi-hour, multi-day runs. And what I want you to keep in mind is summaries lose resolution, but when you use verbatim compaction, you're able to retain resolution. And one intuitive example that I like to frame is, imagine that you have a test case that's failing. And in the summary case, the summary might even just forget that case, or it might summarize it in a way that it's not intuitive what the error was. But with verbatim compaction, since the model has this delete context tool in Atomic's implementation, it can decide which context is relevant. So you can prune test cases that passed, and you can instead keep the test cases that failed in this next compaction cycle, and you have the direct resolution of that output. So the model can actually recover much better than was possible with summaries. So context controls what each stage knows. Next, I want to go over what happens to finished work when the process stops. And this is where we get into the idea of durability. So durability keeps finished work when the process stops. And the definition here is that part of the system makes work durable. It schedules stages, it checkpoints every completed step, so you can roll back, or if there's an error, you can resume from where you left off. And if you stop it mid-run, it resumes from that saved work instead of starting over. The nuance that I want you to understand for a resumption is that there are technically two models of resumption. One is you're resuming in the middle of a context window, and the other one is you're resuming some, like in a typical situation, there's still this idea of durability where you restore from a checkpoint. But what Atomic does, it introduces this granularity where if your session crashed in the middle of its trace, it can pick up where it left off in that trace. So there's this dual checkpointing that happens, one that happens at which node in the graph you are, and it tracks the dependencies of that node. And then the other one is, once you're in that particular node, if it's a language model's context window, it resumes from that exact checkpoint at which the failure happened or where that pause happened. And this allows the model to maintain its thinking trace and also have the ability to be more intelligent, because it improves the reliability where you can just resume it from the work that it was doing. And this is beneficial because models can modify the file system in the middle of a workflow. And if you don't have a good revert mechanism, you end up confusing the next iteration of the model if you resume it. So in order to solve this resume problem, that's why you want to just leave off exactly in the middle of the trace where the model was, so it has full context of what it was editing. So
wow.
Wow.
Yeah. Like, this is blowing my mind right now. I don't think anyone has really gone into this level of detail that you're describing that I've seen online in as far as agentic engineering. And if you're watching this right now and you're liking this, definitely hit the thumbs up, share this with a friend who needs this right now. This is going to be available as a video on demand. So after the live stream's done, you can go back. I'll have chapter timestamps. I'll have the video also kind of edited down so that because the great thing about a live stream, I see your questions streaming in and we'll get to them, Jay. Also Transported Reality and some other folks, keep leaving those questions and we'll get to these little breakpoints where we kind of get to answer them. There's a lot of really great topics. We're covering everything as far as from loops, graphs, just demystifying everything, context windows. Watching this, you may have to watch several times to kind of really understand these concepts. Because if you have been prompting, maybe you're an engineer, but you haven't really kind of gotten into the weeds of things. Alex has spent a tremendous amount of time working in these systems, working with other people with really large code bases and trying to implement them and trying to get the most out of what they're doing. And there's all these little paper cuts that you will be hit. And so you may hear people talk about their experience using a model like I do. I frequently talk, oh, this model sucks or whatever. But, you either make guardrails or you make your own workflows to kind of circumvent that or make it a little bit smarter. And I don't think anyone has gone through the level of detail that Alex has here. And Atomic is open source. You can grab this repo right now and start really just cooking with it if you wanted to. So I've dropped a link in the description, and also if you're on X, there's also should be a link here. You can go start playing with it. Open source, start using it. It's basically forked off Pi. And has a bunch of other runtime stuff that we're getting into. But before we even get into that, we're just kind of doing a little bit of a masterclass first. And so I just want to kind of make sure that y'all are still vibing with us, and that you're leaving that comment and that you're sharing, and kind of keep dropping your questions, because we definitely see them. And I just wanted to say amazing job, Alex. And I want you to continue with this, because this is an amazing part, the durability and human judgment. This is really, really cool, because this is usually where the models can start steering into what we call slop land, right? From the previous
definitely.
context compaction, the summary, like things, it's just like you start to get dementia, because now you don't remember what really happened, and you're just trying to make that as clear as possible, have them to get to this stage, because they've done all this work to get to this stage. And now that they've gotten here, if they don't have all of the data that's clear in front of them in the table to work from, then how are you expecting them to have good output? So this is probably some of the keys that you'll have, and we'll be able to kind of dig a little bit deeper here. So thanks, Alex.
Yeah, of course. And one thing I want to mention when we get to the live demos as well, if you build any interesting workflows and you want to share it more broadly to the community, I'm happy to repost it if you tag me that you created this workflow, and you can feel free to message me on LinkedIn or X. And I think we're really trying to build a community of engineers who care about the way that they approach the craft, and workflows are also shareable. But this is kind of a preview. We also have a Discord channel as well for Atomic, in case you want to contribute or you want to discuss about agentic engineering. But we'll get into like more of the technical details and actually apply this to real code bases and real demos. Awesome. So as I was explaining, the resumption model is very nuanced, and you have this idea of resuming and then redispatching and then replaying work and then continuing this incomplete work, as I was explaining. And then another part is where humans participate in the system. So if you look on the right side of this diagram, we have observe, steer, and control. So one challenge with workflows is, how do you get human in the loop right? So I put a lot of attention in how can you steer a workflow mid-run. And so there's this idea of being able to pause workflows. And when you pause a workflow, it pauses all of the dependent nodes in the DAG so that the execution doesn't race, or it considers the dependencies. So resumption just works. And then there's the other part. Turns out that steering is much more nuanced than I had originally thought. Because typically when you steer a single chat, the model is continuing with its train of thought, but sometimes, and this is where reliability comes into play, the model, I noticed, for example, even GPT 5.6, will just answer my question and stop working. And this is where things like deterministic hooks come in that Atomic already does for you, that tells the model, continue working like the user was just steering you or asking a question. So it handles all these edge cases where the model could just stop out of nowhere by injecting these hooks where you can audit them and actually see what's happening. So if you pause an Atomic session and then you steer it, it will actually auto-inject a continue message after it's done, and that ensures the model actually completes the task that was assigned to it in that stage. So this is a further level of reliability that's being introduced in a node. And that's why steering is so important to get right in workflows and how it differs from stages. Because in a stage, you would be steering the system and saying, wait a minute, why didn't you continue? But in Atomic, this is running autonomously over hours or days. So the system needs to be able to recover that thinking trace. And it shouldn't just stop. It should have some mechanism where you can control that. And this is where we get into control, the pause, interrupt, quit, and resume functionality. Here, interrupting, as I mentioned, pauses the dependent DAG nodes. And then quit and resume. Quitting is just like regular quitting a workflow, and you can resume it after that execution. And then you can even have the model, if there are failures in the workflow, the model has access to workflow primitive workflow tool primitive, and it can actually self-correct itself. And it can say, oh, this workflow that I created actually is suboptimal here. I need to instead modify the workflow to do this. So the workflows themselves do automated QA testing. You might notice that as you use Atomic more and get into more complex use cases, where I've had workflows that will fail mid-run sometimes, like dynamic workflows, not the built-in workflows. And those dynamic workflows then can self-correct themselves and actually adjust the way that they approach the problem, which is, I think, pretty interesting emergent behavior.
Wait, so that is, I mean, because I've seen some of this before, and it's like the harness kind of slows it down. And I wrote a text to, not a text, I wrote a tweet to Thibaut on Codex saying, hey, can you guys just please work on your agentic runtime, because Codex feels like I'm sipping intelligence through a straw. So I'm seeing bits and pieces of the way the model behaves, but because it's told to just be like, no, just do your work and just get out as fast as possible, that's kind of the limitations. And so what you're doing with Atomic, being a fork of Pi, you have so much control. And sometimes, I don't know if people have done their own implementations of Pi, it can get crazy. And if you spend a lot of time in prompt engineering, you have to optimize these little pieces. And it's part of the reason why we're having this masterclass, is because now I'm learning a whole much more about what the models are doing. And this changes almost every release, and you kind of have to really stay on top of them. And so that's why it's really important. So if you want to find out some more information, Alex, we have some links in the description as far as like his community and so forth for Atomic. If you're an engineer who's wanting to build with this, just like me, who's anxious to keep stuff in production really high quality, high value, but then you can use your own existing subscriptions, right? I'm using my own ChatGPT subscription. I'm using my own Anthropic subscription. I'm using my own Cursor subscription too, right? So just throwing that in the mix, because it helps with verifying, works for testing. There's certain workflows I can run a VM a lot faster because Cursor has a lot of great infrastructure that's spun up and ready to go for my build process. So spinning up something won't take much resources. It's already part of my plan. People have different plans and different configurations, so you should be able to do that, which is really kind of the best part of this being open, and it's just out there, and it also works on all these platforms. And this is incredible work, and we're going to keep diving deeper on this. And let's see if we can just answer some quick questions. I know some people had some stuff. Somebody had some questions on verbatim compaction. Is that like an Atomic only feature, or is that something like, talk a little bit more about that?
Yeah, it is an Atomic only feature. And if you go back to my screen, there's some documentation on how compaction works. And I actually went down this rabbit hole of figuring out how to optimize compaction. So there's the full explanation of how verbatim compaction works. And also Atomic itself, I treat as an educational tool as well. So Atomic has access to its own docs, just like Pi does. And I've curated it specifically so the model can extract information that it needs based off of the user request. So you can install Atomic and just ask, how does compaction work in Atomic? And it'll explain to you, and it can generate diagrams for you. And you can use that as kind of a way to learn about these different agentic engineering approaches. So it's instructive in that manner as well.
So not only did we get a masterclass today, we get like the actual system that you can ask questions to, that you can teach yourself.
Yeah.
If y'all need to smash the thumbs up on this. This is crazy. Who was doing this? We're not funneling you to go in and say, okay, now we're going to charge you $5,000 to get the sauce to talk to the AI. It's like, it's free. It's open source. Go use it. Go build. We want high quality software. I, as an engineer, am super curious. I'm trying to find other people like this. I know you're out there, and other people who are trying to build high quality systems. And, I think it's just amazing that you're just doing this work and putting it out there. And it's just, it's straight up out there. And this is an amazing chance to just be on this live stream to ask these questions, because it's like, it's crazy. So like, y'all go check it out for sure. Are you using the ATA protocol in Atomic to facilitate the communication between agents? Because you talked about intercom earlier. Yeah.
Yeah. That's a great question. ATA is not used. There's the communication format for Atomic is inspired by Pi Intercom, which is a Pi extension, but I've customized it to improve like the efficiency of peer-to-peer messaging. So if you go to the Atomic docs, or if you just ask Atomic, it can explain how intercom works. But it's a very reliable way, and we'll see some cool demos later of communicating with subagents or sessions. So one of the cool examples that I was telling Ray about last night actually was, let's say that you have a subagent that has done some exploration and you want to hand off context between one session to another session. Instead of like thinking about the forking of context as a deterministic command, you can use intercom, and so you can you can tell Atomic load your intercom module and then connect with that other session. And instead of forking the context, you can tell it give an appropriate handoff message and just message the other agent. You don't even have to copy paste anything. And you can do this for, let's say that you have 20 sessions and you want to fork each of them in their own specific ways. So you can actually like spawn a pseudo swarm in that sense, and like have each do subtasks. So it can get pretty powerful.
That's insane. And this can happen on the fly as a human steering it. It could even be a part of a larger instruction set. For example, like a workflow that I have defined with waves. And this is kind of something that Alex will talk about a little bit later on, or might have to do a whole different live stream dedicated to that to show some of this in action. And I feel like right now there's so much to take in this masterclass. This is just packed full. Every single chapter we've been going through, from like the, what is a graph, what's like how the control flow works. We're talking a little bit more about the agentic runtime and these workflows. There's going to be a lot to unpack. And if you want a part 2 of this, definitely let us know. Also, if you want to do maybe like some type of meetup, maybe we'll meet up this weekend where we all kind of get on a call and just start asking questions, and just you've tried it a couple times, give this a spin, and maybe just try to do stuff live. I think we want to do that. Also, if somebody wants to sponsor getting Alex down to San Francisco, to the Bay Area, so we can do a working session, or sponsor me to go up to wherever you're at, I think, is it Washington or something? Or somewhere in that area. And we have a session there for those groups of people. I think that could be really cool. We're trying to really just put this stuff out there and get more people who are really wanting to build with these products. And I think there's just an amazing amount of information that I can't believe that's out there. This is for free as well. My review session skill, I think it says, calls fresh agents, stating what the goal of the work being evaluated without providing its full context, and ask for a review of the changes evaluated versus the goals. So I guess this is this person's approach to how they do their reviews and stuff like that, I guess.
Oh, nice. Yeah, one thing I wanted to mention is you can translate your skills to workflows if you ask Atomic to convert it to a workflow. So I'm not sure. One of the progressions that I wanted to mention or emphasize is we went from prompts to skills, and Ray also mentioned this in his post, but he mentions here we've evolved from prompts, skills, workflows, from prompts to skills to workflows to graphs, and this essentially is saying that right now I think most people are using skills in a way where they're describing first do this, then do this, then do this, and if it fails, do that. But I think the realization that many people are making now is that those are just actions that you can encode in some state machine. Like those are all states that you can encode and go to, and then actually be able to audit, instead of just relying on the thinking trace of the model. And so I think we're going from create a skill to do this to convert that to a workflow or a graph that can monitor what's happening and that I can inspect as it's going.
Wow. I think that's incredible as far as like just the way that this stuff is evolving. And this is kind of what maybe when you see some people posting about workflows or graphs or something like that, because this is kind of what we're realizing. It's like we can't have one context. The context window, like Alex said earlier, is very precious. So if we fill that up with all these instructions, you're now leaving more randomness for things at a place that should be more, how do you say it? Like it has a state machine, has much more verifiability,
Right.
right? And just the consistency, so that whenever it does get killed and comes back up, or the environment changes, as the environment changes, the agent is, able to then make the better decision at that specific moment, no matter what happens. So it's just kind of an amazing, it's just principles of software engineering, control flow, basic things,
Exactly.
but it's being reborn again. And it's actually maybe more important than ever now, because if you have now an intelligent machine, that can be automated. You don't want to waste those resources. And so this is a new way of thinking about things. It's a little bit definitely more advanced. If you've just been doing some prompting with ChatGPT, like this is kind of a lot to look forward to. And there's a lot of different concepts. So don't be afraid, because you will get there. Just after doing this for a couple of months, you'll start to figure out some things. And if you've shipped software as an engineer, there is hope, because I wouldn't take everything at a surface level saying, I've tried this model and it's slop. It's more of like, let's build that discipline now. Let's start to understand what this really means. Let's go start to build some workflows. And if y'all want to build this weekend, let me know, drop it in the comments, and then we'll probably host a session with Alex or something, and try to get his time, and we can kind of build together, because I think a lot of people who are engineers are seriously wanting to adopt AI, but aren't really too impressed with its results. And to make this more reliable, and like there's a lot of tooling here for free that you can just adopt within your own internal network, whatever, you don't need, if you have models or whatever stuff that you're running, you should be able to configure them on top of this type of stack, which is amazing. So I think this person had a question here about the Brownfield code bases. So what are the best practices to integrate atomic similar structures on Brownfield code bases? It's like actually quite simple, right?
Right. Yeah. All you have to do is install Atomic, and so we'll go over in real world scenarios, but I actually think that Brownfield code bases are where Atomic shines, and it's optimized for existing processes. So the first thing I'd recommend when using Atomic is start with the built-in workflows, and also you can ask Atomic, how do I approach this problem? And then I expect people will start using like these built-in workflows. Like there's a goal workflow that's more reliable than the /goal in Codex. And then there's also Ralph workflow, which has like research and verifier stages and orchestrator stages that spawn parallel agents. And it has these adversarial reviewers. So I would recommend just starting with creating a ticket on GitHub for the feature that you want to build. And we'll go through how you can actually apply this to a production code base. I don't want to just talk about it. We want to do it. And you can just ask Atomic to tackle this issue in a separate Git worktree, and it'll spawn a workflow for you and run that in the background. And then you can actually probe Atomic, what's happening in this workflow, because it has full encapsulation or understanding of the workflow that's running, because it's plugged into the workflow tool itself. So that's how I would recommend using it. And then once you become more advanced, you can start to build workflows tailored to your code base and your style or your team. Because I think the power comes from customizing the workflow, or uber customizing it so that it represents that particular code base's practices. And I think that's what has led to the best results I've seen.
Wow.
And I've seen engineers who are telling me, oh, we built this custom workflow and we saved at least 1.5 hours per ticket, at least. And that's being conservative, is what they told me.
Yeah, I mean, it's literally simple as like, people used to spin up Jenkins, people used to spin up their various CI things. That could be part of the loop. Maybe you want to kick off a suite of tests that aren't always like the full suite that's going to take hours. You just need a smaller subset. You can have an agent intelligence say, okay, I touched these lines of code. This is the higher risk. Here are some dependencies. Let me just run these first as a quick smoke test for 5 minutes. And then if I need to pull in something bigger because I'm starting to see an issue, let me just also do a second round or something like that. I was just thinking as a QA engineer, not even thinking as a person designing an agentic system. But with that type of experience and background, you can see how powerful this is. Definitely. Back in my day when you has to write code by hand, which was like not that long ago, actually, which is kind of insane. But you would have to like literally keep suites of like plists, like files, something to describe these tests. And if your UI changed or if anything changed in your workflow, you'd have to rejigger them, sit down, review them every so often. And no one goes back. They just rerun the whole suite of tests. Like, let me just YOLO add to this golden suite. I'll let it run for like a week or something and then come back. And then you'd have to you get failures back from your tests that you would just say, that's a known issue because the code changed. I'm too lazy to update that. It's like you get down these crazy rabbit holes. No more. That is not what we need anymore going forward, right? This is what agents are for. and workflows and various things. So yes, it does work inside of your existing subscriptions like Claude Code. So that's going to be a really cool thing. So you just
Yes.
slash login. You'll see the stuff on the repo. Obviously, yes, we're definitely have to do a part 2. We're already an hour in, and probably towards the end, I'm going to show you a little bit of what I've done so far. And then maybe have to do a part 2, maybe do something this weekend, maybe do something next week, because there's just like a lot that's going on. And I think there's just so much knowledge here to share. And I'm glad we're taking this little time to kind of take these little breaks to make sure we talk with everyone. So yeah, it does have some pre-installed skills, obviously, right? As far as Atomic.
Yes, it does.
Yeah.
Yeah, there we'll get into that, but there are a few primitives that I found useful when building projects that come as skills. But I won't. The emphasis is on the workflows. So Ray, if you go back to
Oh yeah. Here you go.
the
Yeah.
my screen, just showing, there's a research code base workflow which will explore your code base, and then there's a research code base skill. I mean, and then my favorite skill is the create spec skill. So this is heavily inspired by looking at high quality specs across Microsoft, Amazon, Google. Google is, I think, Google, Apple. These are all well-known companies for creating good PRDs, high-quality PRDs, and so I translated that into a skill. And if you use the create spec skill and then you use a workflow with Atomic, I've seen results where I can one-shot or zero-shot a complex implementation just because I can align my intent using this methodology. So create spec skill you can think of is similar to, for example, Grill Me, and it's a combination of all the approaches that I've seen work for framing a problem to a coding agent. And then it's condensed, and it'll ask you specific questions about how you want to implement something. And I think with these latest models, it's more important than ever to have a precise spec. And that's because they have the tendency to overscope too much. Like if you were doing a migration or if you're making a change, I've seen some people complain that the model will try to change their entire backend infrastructure just because it deems it suboptimal. But that's something you never want, because you end up with a 50,000 line PR that nobody wants to review when you could have had maybe multiple 100-line PRs. And we'll get into like things like you can do with like GitHub stacks, and yeah, basically you avoid that mess with create spec. And then the other primitives are to help with the internal engine like subagent and intercom. Yeah. And there's prompt engineer. Highly recommend this one if you want to do meta prompting. It feeds from the docs for GPT 5.6 Opus 5 and like maps the right prompting practices to each of them. Ooh. And then my other favorite ones are TDD, test driven development, and Tmux and Playwright CLI. These are like for one of like the cornerstones of the verification, where it can spawn Tmux sessions and Playwright CLI sessions. And then a light parse is an underrated one. This gives you built-in primitives to extract PDFs, and especially if you're giving design docs, you can pass that in, and Atomic will know that it should parse it with light parse, which is one of the best open source PDF parsers. And then Impeccable, a lot of you may have heard of it. It's incredible for creating high-quality designs, but Atomic takes it one step further. Atomic actually gives you an open Claude design workflow, which performs incredibly well for taking a design that you're inspired by and transforming it into a high quality design that considers your taste. So it like has human in the loop. It has a bunch of advanced features where you can steer the system and actually build high quality designs if you're into web development or design.
Wait, hold on. We have an emergency. We only have 20 likes on this stream. We need more likes. My guy literally just dropped the open source version of Claude Design. No one is talking about this. You're not seeing this type of content anywhere else on YouTube or even on X. People like are vague posting and they may not even know what they're saying because they were probably at a convention or somewhere listening to another engineer talking about it. They don't even know enough to share that back. I'm bringing you the source of people who are actually working on these types of things right now live, and you're able to ask these types of questions. All in that repo, Atomic repo. I'm telling you, this thing is crazy full of all this stuff, open source. You can bring your own ChatGPT sub. You can bring your own Claude sub. You're not going to get penalized yet, to use your sub. I'm using my $200 a month plan. And it's like token efficient. It generates this workflows, has the intercom stuff, has so many things that are in there, existing skills, combining all these types of things. And Alex is working for Microsoft as a research engineer. And on top of that, a lot of people at these big FANG companies are trying to ship stuff in production, and they want a better like system, right? It's not the harness now, it's the agentic runtime. This will make the models feel like they're actually getting the full capability of their intelligence. This is fairly new, and we're seeing new behavior of these models because they have basically more of a map and a way to have these control flows that we as engineers who've done software for a long period of time can start to kind of send them off in those directions. But that becomes encodable because now your other team members can take those workflows and apply them. And just as like a new person who joins the team, they can immediately start making changes into your repo as fast as possible without being tied down to one proprietary or one specific model provider, service, or whatnot. And this is here for you. So we got to get those likes up. We had 20 likes. Now we're at 28. We got to keep getting those likes up and share this with a friend. This, for those who are just joining into the live stream now, this is a full-on live stream. We're going to have this turns into a video on demand. So you can come back later on to your X post, to your YouTube, to LinkedIn, to wherever you're at. And there will be timestamps down below so that you can go back and reference them. I will also be editing the footage. So afterwards, I'll be cutting up the footage. So you'll see little clips and things, but you'll also have like a fully edited thing. So it'll kind of break apart some of the little breaks that we've been having and the discussions like this that we're having right now with you, because this is our time as an audience to really connect as a community, but also share this, joy and ask any questions that you can right now, because we have these little stopping points. And also just appreciate Alex for his time to share this wealth of knowledge and research with us, because like we said, like the level of detail here is just unmatched, just in one stream, right? Like it's so amazing, and I'm just super hyped that you're here right now. I mean, a lot of people are also saying, how thankful they are and so forth. So I definitely do appreciate
of course,
that.
Happy to spread the education. I think one of my goals is making engineers more aware of the technology and how they can use it, and how to be practical as well without falling into the hype train or getting discouraged from a post that like seems too good to be true.
We've all been there. Somebody says a post and it's a link to their like Claude wrapper. I'm like, you didn't even try, bro. Like you just made one wrapper with a skill on it, like one skill file. Come on, bro, get out of here with that. No, this is high quality stuff right here. We're many people are sleeping on this, but I feel like at the end of this, you're here early, fam. Y'all here are early, and oh man, let's just keep cooking, dude. This is amazing. Let's go.
Can you give me 1 sec? Just gonna take a quick bio break.
Sure. Yeah, cool. Yeah. So yeah, this is. Let me just also kind of do some demos and stuff, because I know people are popping off online. Y'all are sharing this stuff here, and so what I'm gonna go ahead and do is kind of do a quick thing here. I'm gonna just show you a little bit of like my workflow while he goes and takes a little quick break. So I'm going to SSH into my machine here, and I'm just going to get this up here. So this is what it looks like. So one of the things that he told me was this thing called Herder. If you haven't had a chance to install it, HERDR, oops, I will have a full blog post on this too, HERDR. So install Herder if you haven't had a chance. This is like a way to have your TMUX session that like has these tabs and everything. It is amazing. Let me just put this in the chat as well here. So Herder is pretty fire. You must install this. This is going to change your life for how you do agentic engineering. If you're going to be in the terminal and so forth, it is like undefeated, absolutely undefeated. So I'm going to SSH into my Mac Mini. So everything's running on my Mac Mini right now. And I just do HERDR. And then it just pops me right into what I was basically working on last. So there's this concept of spaces here on the left. It'll show you if there's any agents that are running. And now, because I kicked this off a couple of days ago. And so for my own app, you can see like I've been going on for like a long ass time. So this has cost me $66. I don't know if I use like millions and millions of tokens, maybe five, I don't know, quite a bit of tokens. And so I basically have been working at trying to like merge like this mega PR, but then I found out that I with all those security, like I had some security problems and other things that I didn't know I had because all the work was already done by Fable. And it's like, hey, everything's good. And I was like, I don't believe you, Cloud Code. I feel like there's probably more here that hasn't been tested or looked at. So then this is kind of why I pulled it into my existing project. And when I ran it, I think, let me see if I can go to the very first prompt and I'll show you what that looks like. Very up. I don't know if it can tell me. Maybe I'll ask it. Can you tell me what my original prompt was? And so it looks like a Pi coding agent, which is pretty cool. And so when it kicks off a workflow, you'll see it kind of create these little like nodes and things when it's doing work, but it's pretty much done here. These are little tabs. You can hit tab and keep having new tabs here. And then as far as like an intercom, I did have an intercom conversation up here somewhere when I was doing a handoff. I may not be able to pull it up, but it says,
Yeah, no worries. We'll do an intercom demo as well, so people can see it live. I think that's like the magical moment.
Yeah. So what I asked was this. This is exactly what I asked the agent for this run. It was running like many, many hours, like many days actually. So and this is I have this features agent CLI here, and I'm not sure what it's. I just literally verbalized this, and this is what I need here is a really robust review, almost like a workflow where I mimic a prod deployment, because I had this large feature with a bunch of breaking changes all over the place. And I need to kind of mimic a migration. And this is something that I usually do in my normal testing. It's like I like to test like I'm deploying it somewhere to a preview environment and then catch any bugs or failures and things that I just overlooked. Like, oh, wait, I forgot to migrate the billing thing, or I'm using this API and there's nothing on the other end that's catching it from the database side. There's a lot of these little bugs that you figure out, but then because I'm using coding agents, I don't know if the coding agents actually tested it or if they just said, I wrote something there, or I wrote a comment and you're good, Ray. Like trust but verify, right? So verifying is a huge moat. And this is kind of why I wanted to adopt something that can just give me that peace of mind, but also be able to run overnight so that I'm not having to babysit it the entire time. This is kind of like why I felt this was like a really cool thing for me here. And so as you can see, like it's like, how do we go from the main branch now to like what's now going to be merged into main? Will there be anything in the database that we'll have to trim out, data that's stale, or anything like that, right? Just kind of yapping my concerns before I go to bed. And then there are 8 asks. So it figured out there were 8 different things I needed to do, from security, which were not ready at that time, 26 defects. It found an RCE as well. There was a deployment issue that it narrowed down into like these different runbooks as well. And my migration stuff was not even buttoned up. So if I pushed all this stuff to prod, I would have all of these issues. Right? And the recommendation is to not run it. While Fable told me, I ran in Claude Code to do this review, and it's like, you're good to go. I don't believe you now. See, and I utilized the GPT models. I had an Opus 5 high as well. And eventually I also pulled in Cursor into the mix as well to run some of the Grok and the Composer stuff to help me speed up the file verification and all the other things I need to do. So your instinct in the first message was right. You said, I'm not sure that it's ready. It isn't. And for the reasons you listed, the worst findings was an RCE in your own migration script. And the second worst was the repair meant to fix things that broke the working feature. This is so good. So this is an example run that ran for several days, and you can see it just kind of orchestrates itself. Is there a way to see what the workflow node was for this, Alex?
Yeah. Are you resuming a session?
Yeah.
Okay. If you use /workflow resume,
Oh.
you can select the workflows in your history for that particular project.
Oh, I see. So there were several here then that had. Oh,
Yeah,
and this had 176 checkpoints.
Yeah. So this is the durability aspect. So if you enter on that, it should, it might take a few seconds because it's a large one.
Oh my
but
God.
it reloads the entire graph.
Wow. Yeah, because these were all the different things that needed to be checked for it to like actually work for my.
Yeah.
What? This is crazy. Workflow. So workflow.
/workflow resume.
Resume. Okay. And I can
you
see
can resume
CLI.
paused or failed workflows as well. Yeah.
Oh my God. Yeah, this one's still running. I guess repairing something.
Yeah, well, this one it's looked like you was paused. So if you want to quit a workflow, you can also use
Ah.
slash workflow quit. Yeah.
Oh, I see, I see. And then I could even tell it to like, it's like Control X, I think, to go back. Okay.
Control X, yeah, to go back, and then
Wow. Yeah, because this is part of the original review, and it did some synthesis and adversarial challenging, and then it ran probes.
you
I
can
never
click
wrote
into
any
it.
of these workflows, by the way. This was done just off that one prompt. So all I did was give it that one prompt where I told it like I was afraid, I have all this stuff that's going on. I don't know, you go figure it out. And then from there, 2 days later, here I am. you know?
Yeah, so while we're on this screen, you can actually click on nodes. So tool nodes can't be clicked on yet, but like you can connect to a chat, and you can also use your arrow keys to navigate. Those are like tool nodes, yeah. So this one,
Ah,
and you can actually audit what happened, and you can ask the main chat model what happened, or you can even
oh,
steer these sessions are attached, and it's actually funny. There's a lot of optimizations to loading very large graphs in your terminal that needed to be in place for
yes.
this. Yeah, I was talking about there are people who are running hundreds of nodes and
Wow.
some concurrently. So it really
Whoa.
needs to scale to that type of load.
And what nodes are still running? Do they need the new cursor workflow we talked about earlier? Okay. So here I am.
Workflows can also be composed and chained. Yeah.
Yeah, and this is the main session where I'm at. And like you could think of this maybe as like the orchestrator thing. And you can see all the other like sub nodes that have kind of been going on. So like if this was just
Exactly.
like a text conversation, it would just be a text conversation to the project manager, whoever's owning the entire app end to end, right? Like I'm the CEO at this point. I'm just saying like, yo, what's the status, right? And so this is it checking up on itself. And you can see how it just like administers workflows and goes down these different alley holes. And the thing that we showed earlier is like, Ray, is this going to just burn all my tokens into existence? And would love Alex to kind of answer what that means for us and what you've been able to figure out here. I don't know if we're going to talk about this too, about like how it decides what models and so forth in your slides. I forgot about this, but yeah.
Well, yeah, I don't have slides prepared for those, but this is a great question, and it's a question that I hear a lot. Uh, we don't have any public measurements available at the moment, but we're working on more benchmarks. But in anecdotal data, I would say from user experience, I was talking about how we save an engineer 1 to 1.5 hours per task. So one thing that I think is underlooked in the way that you measure the cost of these systems is the time that an engineer has to spend then re-auditing the system and going through and understanding what went wrong. And so you have to consider the economics and benchmarks, which is the salary of the engineer as well as the token cost. So something that costs less may not have the same level of quality because you're considering an engineer needs to go manually and fix something. So they've lost hours of engineering time that could be dedicated to something much more important. So like there's this opportunity cost and ROI argument. And I would say on average from the people who I asked, uh, one engineer told me that 12 tickets was, so I have this metric actually saved, $427.52. So that's for 705 million tokens. And that means it's a median of 11.29 per ticket, $11 per ticket. And he also told me that one ticket cost $4.85 and it caught a potential change that would have caused an outage and there was no CI test for. So that was his words.
That's wild. Yeah, there's these things that are just there and they know you should do it. And you have a note somewhere, a post it note, a things to do note or something. You forget
Yeah.
because other fires pop up, the two, right? Holy
Yeah,
smokes, this is really crazy, dude. Yeah, because even for
definitely.
me, right? Like I know I should be testing and doing more stuff. So now I could just kind of hand the stuff off and all the different models are doing different work. For example, Sol X High did this and it merged this, 1,000 lines and deleted 2,000. And the web upload stuff was done by Opus 5 Thinking High. And then the preparation for the contract stuff was done by Grok 4.5 High. And then Sol High Fast did the key lifecycle stuff. And the architecture review, I have Fable do architecture reviews for me. It's phenomenal at architecture review. And so all of these talking to each other is such a huge like boost in variability for like intelligence, but also to get some nice, back and forth conversations started. And then, kind of the agents as it's running can able to kind of steer themselves. And, it's like actually having a nice successful team. And I think this is going to be the bigger moat is like, how do you, codify, how do you use things like this to help, make your high quality software? Because as I ship software and I get more users, I want to have stuff that's just running in PRs automatically and doing all that stuff. And that's the dream here. And this is kind of where I'm going towards. So in these streams that I'm going to be doing, in the coming days and the coming weeks and so forth, I'll be basically continuing to explore what this means for shipping high quality software, having this stuff automated. I'm working on an app called Clippy as well. So Clippy will take my live streams live and clip them. And so I'm working with another engineer on this. So we're basically both prompting, and you can, you already tell if you've just yourself, it's kind of crazy, but working with two people who are using AI who are barely even like reviewing the code, I review the code because I know that like there's some code smells and it's like, but having a system in place is going to be even more important because this is what I want. I want them, no matter what agent they're using, whether it's Codex, whether it's Claude Code, if Claude tries to check it in, it's going to bounce stuff back with enough information at them and saying, oh, this did get reviewed. You're, do it in this way or something. And they should have an even better result because I want that no matter what people are using and no matter what models, they should be able to bounce that back. I think somebody had a question about open models and whether there's like some success with that, or, if you have this system in place, how does that kind of work together with this type of thing?
Yeah, that's a great question. I think it's an important question as well because what we saw, for example, with Hugging Face, when OpenAI had turned all their safety filters off and then accidentally hacked Hugging Face, and they ended up having to use GLM 5.2 to debug because they had sensitive information in their internal state for their database, and that's where open models really shine. And so they use their own self-hosted model. So Atomic can do the same thing via Llama CPP. So it inherits Pi's Llama CPP integrator since it's a fork of Pi. So all the nice features that you have in Pi come with Atomic, and Atomic significantly then it extends Pi's functionality via this runtime. And I have seen great results with GLM 5.2 and Kimi K3. If you want to create workflows with that, that's definitely an option. I would also consider, I guess, if you can, let me go back to my screen, right? The cost per task. What Atomic optimizes for is the Pareto efficiency of the models in terms of cost versus accuracy. And here I'm sharing DeepSuite, which is a popular coding benchmark. It's like the successor to SweetBench Pro. And then there's also a nice benchmark called Frontier Code. And Frontier Code, so DeepSuite is like taking open source issues and trying to flag if they're correctly implemented or not. So it's like real world code bases. And it's not a perfect benchmark, and we might do some analysis on why, but it's like it's one of the best benchmarks that we have currently. And then Frontier Code is also a similar story. It's measuring like would an engineer merge this code, and here we see like even the model capability scaling. If you use a higher reasoning level, you'll notice that Opus 5 actually performs worse when it's at a higher reasoning level. And that's because you don't have these quality gates and it can over and scope these tasks. So even if model quality improves, there's still processes that need to be followed and you need to have some assurance in the system. So just because a model, quote unquote, codes better on a benchmark doesn't mean that it produces more high quality code or mergeable code. And that's where Atomic shines, where engineers like are able to. So one of the engineers told me that he has a 95% merge rate with Atomic, and he's completely moved off of Claude Code for trivial tasks and just uses the Claude Code subscription with Atomic directly. So this is where you start to see the like a principled engineering approach outperforming just the model and a prompt or a set of skills. But the point that so that was like a sub point. But about the open source model thing, Kimi K3 does incredibly well in the benchmark. And what Atomic does is it feeds into these popular benchmarks. So it takes Deep Sweep, Frontier Code, and artificial analysis. And Atomic is self-documenting in the way that it knows what model is good for what task. So it can dynamically create workflows. And that's the screenshot you saw from Ray, where it chose certain models based off of their capability for certain tasks. Still working on making the engine better, and like the selection can definitely be improved, but it's like one of the starts that where you can improve the reliability of model selection or model routing. And Kimi K3, GLM 5.2 are recommended. I can't say anything about smaller models though, since K3 and 5.2 are not self-hostable unless you're a larger enterprise. So I would say as we see these models getting better, maybe that's not out of the question. But for now, I would say very like trillion parameter models are still kind of the leading in the open source, and I would not recommend using like the smaller ones that you can run on your hardware unless you have some real constraint or you have a very, very specialized task that you can optimize for.
Wow. That's so
long-winded
cool.
way of saying I recommend using K3, Kimi K3 or GLM 5.2 if you use open models.
And then I guess somebody's asking if a llama would be integrated somehow. I guess
Llama CPP is.
llama CPP. Okay.
So that comes via Pi's integration. But the beauty of Atomic is just like Pi, it has an extension system. So if you want to add custom providers, you can. So if you want to add a cursor provider, you can add a cursor provider. Happy to take contributions. At some point, I actually tried it, but the cursor SDK needs some improvements to kind of tailor that sort of thing.
They just released something today. They open sourced their agent SDK. Yeah, like literally today. Like they just released.
Okay. Well, if anyone wants to contribute that, happy to take contributions, and then you can use your cursor model.
Yeah, because now you can actually do like cursor agent SDK right into that's because I like spinning up the cloud stuff, and it's super helpful and super fast because the environment's already pre-built for me with my environment variables already secure, and it speeds up a lot of things. Like when I adopted it into my workflow, it like spun off like Grok and Composer 2.5, which are insanely fast and can be good for certain things, but I don't really know the extent unless it's been really benchmarked. And this is kind of where the feedback from Atomic can be really helpful here. It's like, oh, it did well with this, but then it fell through here, and let's just route it to another agent to get some more feedback. Wow.
Yeah, and here's a quick video. You were showing this, Ray, but let me actually, if I go full screen, is that better?
Yeah.
Okay, nice. So here's an adversarial verification workflow that's running. And in this case, it has a worker agent, and then there are 3 adversarial verifiers. These are LM as a judge. And then there's like also tournament style workflows. And here you have different models like competing with each other to determine which one's the best. So you can create subsystems, or you can define like evolutionary algorithms as workflows. And like survival of the fittest will give you the best output or things like that. So you can have models competing with each other, which one did the best implementation. So you can do even quick prototyping. Like one cool workflow is you're exploring an implementation and just ask Atomic, create a parallel implementation with different models, and then you can choose which one's the best. Or you can even automate that with a synthesizer or reviewer panel. There's a lot you can do with this, but it might be like a steeper learning curve, but like there's something for everyone. It has the built-in primitives if you don't want as much effort, but then if you're really a powered user and you become more comfortable with the system, you have that flexibility.
Absolute.
So this is the repo, and as I was saying, if you create a workflow that you want to share more broadly with people, you can @ me on X or LinkedIn, and happy to repost what you have. And I think the best way we can share these practices, the more we can share these best practices, the better, because I think there's a lot of gatekeeping, for lack of a better term, of what are the approaches, and there's a lot of vague information, and people are just talking about the ideas, but they're not actually implementing them, which we'll do after this. But this was a deep dive into the theory of everything, and how these components come together.
That's amazing. Give it a round of applause. Give a like. Give a thumbs up. Follow Alex on X. Like super. Like my guy only had 9 followers before my post, right? Like 9 people followed this guy. Like they had no clue where he was coming from, and it's like y'all like are here early, and not only is he doing that, but also providing all of the resources for you, and then providing that like you could even launch your own agents, bring your own Claude code, bring your own GPT subscriptions, bring your own whatever, load them right in, start asking and using the agent there. And if you had questions about the documentation, about like how that intercom system works, how the context stuff works, how to use a plugin, how to generate workflows, how to do any of these types of things, it will just do it for you. You just ask it. It's so composable. There's so much in there, and it can be a little overwhelming, but it's perfect if you really want to get started on, like basically saying, hey, like I have an existing repo. I just want to accomplish this task. Like you were saying, a bug fix, instead of launching Cloud Code, launch it in Atomic, take a look, and then just, let it do its thing. I think it makes a lot of sense because there are a couple like open source repos where like I haven't really contributed yet because I know they have a higher bar for things. And now I feel like way more comfortable to have more conversations because I don't really know how the code base fully works. And I don't want to just come in sideways with like, hey guys, I, have this like, 10,000 line diff. And they're just like, bro, it's a factory pattern. You just gotta like, it's just 3 lines. here's what you should have done. It's like, well, my Claude Code agent said that, Fable 5's with extra high thinking, the highest intelligence here said this. It's like, yeah, that's not really an issue.
Yeah,
Wow.
I would recommend moving away from just thinking of a single model as the capability driver. And it's like the ability we have now is we're not tied to a single model provider. And you see all these, I think this is like the best time to be experimenting in engineering because you can actually experiment at, like actually test different models, understand which each one is good at, and think about the cost optimization. That's one of the most important things because
Mm.
nobody has infinite budget, and the labs can say that because that's their product, but that's not like there has to be some practicality here as well.
I love that. I love that so much. And that I think very few people are posting publicly because it doesn't benefit them if they just give away all these secrets. If you're in San Francisco having conversations, I think all of these pretty much are happening offline. And so there are smaller groups of people who know a lot of the information, but it's not widely shared. And so as engineers ourselves, I don't benefit anything from just sharing this information in terms of
Yeah.
like whether my company gets $1 billion more or, whatever. I am as an engineer, I care about high quality software, shipping stuff to production so that my users don't kill me. But at the same time, just that full experience is kind of old school, but I feel like in the age of AI, I'm not trying to just delegate everything to the model per se, but then there is a way to do that that is actually more pragmatic and that is following control flow, following software engineering principles that you're hopefully will be able to pick up something today from this live stream, and we'll be able to go back with chapter markers and everything so you can kind of skip around and so forth. There's so much just has been packed in. We're hour 42 minutes in to this whole live stream. And I think like I might have to do just a part 2 because I was just briefly showing y'all a little bit of kind of what this looks like in a repo. And maybe I could just show you how to get this stuff installed right now as like the
Oh yeah,
basics we can kind of walk you through. Yeah.
I was actually gonna get into that, but we could
Okay.
do it together. Yeah, I mean, we could do the herder stuff. I have
Yeah.
something prepared for that if we want to go through that right now.
Cool. I'll let you drive that. I'm going to use the restroom and I'll be right back. So that way you can show people how to, like what's the stuff that they need, herder or whatever. And then like the other things that they'll need to get started. I was giving a brief like little preview, but just go ahead and start like as if I didn't do anything because it's a live stream and there's new folks who have just joined in. And obviously hit the thumbs up as we are just cooking some crazy stuff here. And I think people are saying, thank you so much, Alex. I'm going to study what you've taught intently for sure. Yeah.
Yeah, of course, happy to help. Okay, so I'll do some setup, over the next few minutes, and then once Ray comes back, we can uh, start implementing a lot of these and live demos, and we'll go through examples of all the functionality in Atomic, so you can get an idea of what it can do. Okay. So the first thing I'd recommend, so this is not related, this is like a environment setup thing, is I I would suggest installing Herder. And Herder is like an alternative to Tmux, where it is a terminal multiplexer, but it's specifically designed for agents. And I find this a nicer interface to monitor what agents are doing. You can see there's an agents tab. If anyone wants to add an Atomic Herder integration, I'm definitely open to it, because then you could have workflow monitor status here, and then maybe you could have like a sub layout here that shows the active running workflows for a session. And then you have this idea of spaces where you can navigate between different panes for your coding agent. And to install Herder, the site that you need to go to is herder.dev, HERDR, and then just install Herder by following these instructions. So curl install if you're on Mac OS, and then PowerShell for Windows users. And so I'm gonna leave this up for a few seconds just so you guys can check it out. And I also recommend to use an SSH node for Atomic, because there are long running tasks that run for hours or days or sometimes a week autonomously, and you don't want to lose all that work or have to interrupt it in the middle of work on your local machine. So definitely, if you have a Mac Mini lying around, or if you want to lease an instance like an EC2 instance, or on Azure, a VM on Azure, that's definitely the optimal setup right now, where you install Herder on that VM, and then you run Atomic in that VM. So those are kind of the prerequisites I'd recommend. And then Atomic works just like, if you're familiar with how Pi works, there's this login functionality, and we'll get into that. But I would
Have you
say
ever
install
used
Herder. And
exe.dev?
what was that?
Have you ever used exe.dev?
No, I haven't.
Check this out. So this will give you 50 VMs for $20 a month. So it's cheaper than like an AWS instance. And you have 100 gigabytes of pooled, like way more than enough for doing something like this. If you wanted to go even bigger, you can do 50 VMs and like $25 a month, or get a cloud pool or something like that. But you don't even need that much. You just need like this type of thing. So yeah, instead of like with Mac Minis and stuff, or because I think I'm paying like 30 something bucks a month for an AWS EC2 instance. That's pretty large, and I could probably get it down as far as cost and everything and prepay for years. But like, I don't know, I don't want to feel like shackled. It's just 2 vCPU, 8 gigs of RAM, probably more than enough for most things that you need. If you need higher resources, like like even bigger, like 2 terabytes of RAM, then you could do something like that. They're super cool. I really like them. They're super easy to get set up, easy to share for developers and agents. Yeah, durable sandboxes that are fast, secure, and shareable. So this is actually meant a lot for. I wish I was sponsored by them. Like but they're such a great product. I really highly recommend them if you haven't had a chance to check it out. So you can have all these different tabs and do that stuff here. So yeah, definitely another alpha tip here if you haven't been building with this type of stuff. We'll save you some money, I guess. Yeah. So raised 35. Okay, cool. Awesome. Yeah. A little startup. Really cool stuff.
Nice. Sweet. Yeah. So any VM provider, and after you install Herder on that VM, you should install Atomic. And to install Atomic, you can use npm, pnpm, or bun. I install with bun, but your personal preference. And then Atomic is supported on all platforms, so there shouldn't be issues. Recently added Alpine Linux and Muzzle, if you use that as well. Okay. So once you installed Atomic, I'm now going to switch the sharing to a a remote session to my Mac Mini, and we're going to go through and practically implement or discuss like everything that we've been talking about in terms of theory. So let me switch to that session now.
Cool. And I'll get that over here. Awesome. Yeah, appreciate all the questions. So are there voice capabilities? Ooh.
There are not voice capabilities, but if open to contributions, I like to have voice capabilities at the OS level because I think like it makes more sense in terms of the integration because you can just use one ASR capability, automatic speech recognition, for your entire system, and I think it debloats the core experience.
I guess another person kind of brings up an interesting point. How would somebody who has lots of skill files, plugins, the Matt Pocock thing, the GBrain, the Anthropic stuff, because I'm kind of in the similar boat. Is it gonna make things messy, or should I get rid of them and just go all in on Atomic, or like what's kind of like the game plan if you're thinking about somebody who's in these shoes right now?
Yeah, that's a great question. I think Atomic is meant to complement the infrastructure that you have. So if you have specific skills or ways of approaching things, Atomic is able to understand that context, and adding these domain specific skills helps. Another thing I'd suggest is if your skills are aligned in a way where you have step 1, step 2, step 3, I think that's a natural workflow. So I would experiment with prompting Atomic to convert that skill to a workflow, and then saving that workflow. Atomic has a workflows registry, so let me, since we're on that topic, let me share that as well. So if we go to Atomic workflows, there's a public registry where everybody can contribute their workflows and submit PRs, and you can easily install those workflows in your local instance. So we can create this community of open source workflows that others can use. There's a few that exist here already. Like there's the one thing I was talking to Ray about was I copied the exact Codebase migration workflow that Jared did to port Bun to from Zig to Rust, and essentially took all the methodology from his blog, and you can run that for any Codebase migration.
What?
You can play
This
around
is
with
crazy.
it as well.
Hold on, you got to repeat that again. I don't think y'all missed this right here. My guy literally has the sauce, the recipe, the ingredients to reproduce what Jared did from Bun at Anthropic. He works there now. Anthropic acquired Bun. Bun is the runtime that runs. It's like extremely fast, very performant. It's a lot of people use it over NPM because it's just crazy fast, space efficient. It's just like there's so much things. He ported that thing from Zig to Rust. It cost him over $100,000 in tokens. And there was a whole blog post written about how this is being done. It scared a lot of people because they're like, oh my God, like you can actually start doing these because this would take many years to do it. There's a whole explanation. My guy got roasted on his by other people from Zig community. But the important thing is that in Rust, a lot of stuff can be verified at build time, which is kind of the more important part. And not only did they fix issues and cost less regressions, but there's a whole slew of things that benefited from just going to Rust. Fast forward to that. How do I do that as myself as an engineer, right? I just read his blog post. I don't know what to do. Like, it sounds all fancy, woo-woo. Do I have to have Claude Code? I mean, it sounds like an ad for Claude Code, right? It's like, okay, I have to go buy more Claude Code, sign up for 1 million tokens or something, No, you can use Alex's Atomic thing, and this is defined in a workflow. He did a lot of the work. You can create your own workflows and then reproduce kind of that. Not that necessarily you're going to port from Zig to Rust yourself, but you may have some ambitious projects that you want to do following a similar methodology, but you can bring your own Claude Code account, right? You can bring your own GPT account. You can bring your own Kimi account, whatever, and it will just figure out what models to use as part of the whole Atomic thing, which is what we've been talking about for the last hour and a half. And holy smokes, this is really crazy. So I was just kind of putting that in perspective so you really understand how powerful these types of things are. And this is open source. So the design stuff like Claude has, there's a version here that's open source. These types of workflows, open source, open source. So this is how important it is, like, for us to start building a community to keep sharing and to keep pushing the bounds of agentic engineering, which is why I felt like this masterclass was sort of needed for us to, if you're just getting started, if you're working with AI agents, you've been prompting them, you want to take your skills to the next level, take workflows to the next level, graph engineering, you've heard of that, a lot of sauce going all the way back from the beginning. So I'm excited, and I'll let you kind of keep going here because I just wanted to kind of make sure that PSA was out there to kind of make sure to see if we're picking up what this guy is putting down. And it's like, he just casually just saying that. So it's like, oh yeah, it's just this, it's like, bro, like it's a whole, like, another depth. I mean, that could just be a whole video by itself, but man, this is insane. So yeah, likes and thumbs up, folks. Y'all get on this. Let's go.
Yeah, this is definitely a video in itself. But yeah, the process that Jared took, and it actually, this is actually an advanced workflow. It shows you how to compose sub workflows. So one of the core features in Atomic is that when you define a workflow, it can get imported into other workflows. So the execution graph just gets unrolled, and this allows you to modularize your workflows actually. So you can treat workflows as things that you check into your code base. And one of the core ideas is that workflows should also be modular. And this just allows you to build incredibly powerful graphs because you can take processes that are isolated and combine them into larger graphs and then add human in the loop nodes for review or delegation. And so you can continue to expand like this as a network of workflows. And then there's other ones as well, like there's a spec-driven development one. My other favorite one is the babysit PR one. And what it'll do is you can do this inline with Atomic as well for your own CI, but you can ask Atomic to loop until CI is green, and what it'll do is it'll create its own dynamic workflow that will iterate until CI is literally green. Like you have guarantees that it won't stop until CI is green. But if you notice some other, like if you just rely on the model itself, it just stops, and you could have some broken state that it claims to have finished. So this is my other favorite one, and it just saves a lot of time since it's so annoying to have to prompt the coding agent. Oh, you missed something, and then oh, actually you missed this too. You missed the grep feedback, or you missed the you missed the code review, or you missed the Copilot code review feedback, or things like that. And this helps with that problem as well. Yeah, but this is just some examples of what you can build.
Very, very cool.
Now let me share the my terminal.
Cool.
Okay. So I'm in a Mac Mini session right now. This is you can use Tailscale for additional security. I use Tailscale, and you can even when you use Tailscale, the nice thing is you can use things like Termius, and you can actually monitor workflows from your phone in that sense. It's like a hacky way to do it, but if anyone's open to adding extenders for phone or like mobile, you can open to contributions. So I already installed Herder on this node, and when you open Herder, you have a 2-pane layout. You have the spaces and you have agents. Herder has this nice thing where it natively integrates with some coding agents. Again, if you're interested in adding a native integrator for Atomic, that would be super cool because what you can do is like monitor agent sessions, and better yet, workflows themselves could be visible in this pane. So if anybody wants to contribute that, definitely open. I think you'd have to add it to the Herder repo directly, but Atomic is a fork of Pi, so it should be easier than like starting from scratch entirely. Okay, great. Now let's actually open a demo project. Okay, so I have a basic repo. I did some initial setup, and the initial setup was just installing Herder and then installing Atomic. And I guess I'm not sure what's the best way to share this. Maybe should we share this Markdown script to people? I'm not sure how. What would be a good way?
I could post it to my blog. Yeah.
Okay. Yeah, Yeah, because there's some specific instructions for the initial setup.
Okay.
I just had Atomic generate like a 0 to hero of all the practical tips.
Yes.
But let me go back and explain how I set up things, and then we'll get into the actual example. So
Perfect.
let me share that screen of my editor. And okay, so we set up herder, we installed Atomic, and then I created a repo, uh, or a repo for this demo, and then I told Atomic to create like basic boilerplate. It knows if you ask it to do all these things, it has access to its own documentation, so you're not missing anything by like skimming through this boilerplate. You could just prompt it and it'll figure this stuff out. But essentially, what it did is it created a basic JavaScript repo or TypeScript repo, and just have some basic functionality, and then it has agents.md, and then it has just some email validation, for example, and fetching user IDs. This is just a dummy code base that we can quickly iterate through, because otherwise workflows would take hours or days sometimes, and I want to quickly get through the core concepts. And then there's some servers, and just threw in a security vulnerability here so we can actually see how Atomic will handle that. And also created a custom agent file. Atomic is similar to Pi, where you can define custom subagents. I did modify this because it uses Sonnet 4. I just had it modify it to Opus 5 and GPT 5.6 as fallback. The nice thing about Atomic is it's fault tolerant. And what that means is if you have an API error or you got rate limited for a particular provider, it can fall back dynamically to different providers. So it has robust validation logic that'll check for rate limits. It's extended the validation logic in Pi, because Pi is actually limited in some sense where it can't detect some transient failures I found. And then it'll fall back to the next model. And then Pi, this is a key detail, will not switch back to the original model that you intended for the subagent if there was a failure in the middle of a chat. But Atomic will intelligently fall back if you can access that main model again. That way you get more consistency in your results. These are some small harness details that are important, I think.
Oh my God, that's cool.
And there's some other flags as well, like you can control tools. Expect the subagent ecosystem to also be better, since I have a Rust port of the subagent module that I ported with Atomic in a day. And that was done yesterday, but it will be in the pre-release, not in the main release yet, because I want to make sure that stability is good there. And just the other thing is showing how the SDK itself works. And this involved just installing the SDK with the Atomic package. Notice how this is a local install. So it's like adding an NPM package to your local project. It's Atomic itself is a CLI that you globally install, and it's this runtime that can then execute your custom packages, just like Pi. But workflow packages are much more complicated in nature and can scale to different things. Okay, with that said, that was kind of a setup. So the rest of the time will kind of be interactively going through each of these. And let me switch back to the terminal so we can open an actual Atomic session. Awesome. Let me load the. Let me load my own instructions. Okay, as I mentioned, I did that setup. And the first thing I wanted to show with Atomic is, so once you install Atomic, you can spawn it with Atomic. And so I'll show you. I'm running the latest release version. And let me make this window better. Is the font size okay?
A little bit bigger if it's possible. Yeah.
How's that?
I think, yeah, that's perfect. Perfect.
Okay, sounds good. And when you spawn Atomic, by default it'll ask you if you trust the project and the dependencies, or if you trust the packages, and you can click on trust, or the next time you spawn it, you'll get that same notification. And then you'll also see that you need to log in the first time. So just like how you would log in Pi, if you're familiar, there's a /login command. And then when you run /login, you can use a subscription, as Ray was mentioning, or you can use an API key. So think Open Router or if you have like OpenAI API key. But I think most of us are using the subsidized subscriptions, and I highly recommend if you have a personal subscription that you use a personal like explorations, you use a subscription because you get thousands of dollars worth of usage basically for like the $200 plan, which is an incredible deal. And there are multiple providers: Anthropic, GitHub Copilot, Kimi, Code, OpenAI Codex, OpenRouter, Radius, which is Pi's provider, and XAI. So these are subscriptions. I recommend selecting one and then logging in, and then API key is also here if you're interested. But once you're logged in, you should see the model, and then you can switch models just like as you would with regular models. So there's a /model selector, and you can go through and select the different model you're interested in. My daily driver is Opus 5 High, and I'll use that as kind of like the orchestrator engine, and I'll have it do like the main work. But and the nice thing is it's less expensive because Opus 5 isn't executing like the whole time. It's delegating to workflows that we've built, and so that helps as well. And the other secondary fallback model I have is GPT 5.6 Sol at high reasoning. And there's also support for fast mode in like you have in Codex, and you can enable it at a chat or workflow stages level. A heads up, you will burn usage if you use it for workflows. So I recommend only using it for chat if you want that more responsive interface, because it's like 2.5x usage, and I don't recommend that for workflows because workflows are going to be running overnight anyways, so you don't really care about the speed there.
And I think somebody asked about the Anthropic. For me, in my experience, it didn't use the extra usage. It just used my $200 sub.
Yeah, this warning is just like Anthropic could change this at any time, so just a heads up. But for now,
it does exactly
not.
Disclaimer. Yeah. Like if this project blows up and everyone's like, I don't know, like they have. But as of now, we're doing agentic engineering with our own stuff. So yeah.
Hopefully, like Anthropic is okay with the open source community doing this type of stuff.
Yeah, exactly.
So that's the overall setup. And then you'll notice that like you get the basic coding agent stuff as well. Like if you use @ you can reference files. You're all probably used to that. You can execute bash commands as well. So these are all kind of very boring stuff. And then if I say something like, hello, write a 100-line poem, you can queue messages just like any coding agent. And you can also interrupt as well. These are all standard functionality. There's nothing special about this in Atomic, but I just want to show you that you can also get that coding agent experience. So if you use Atomic, you might not ever even go back to your CLI because you get both the CLI and the runtime together. Or you can even spawn Claude Code from Atomic, or even spawn Atomic from Claude Code or Codex if you want. So that's very basic functionality, and so that's the boring stuff. I want to talk about now how does Atomic edit files, because that's an interesting problem actually. And Atomic uses something inspired by OhmyPy, if you're familiar with that project, called Hashline editing. So if we want to edit a file, typically what happens in the coding agent level or the harness level is that it will have to generate verbatim the exact content that it wants to replace, and then the new content, which is actually token inefficient, because why would you want to generate the content that you're replacing? You just want to replace it with new text. So Hashline editing takes it farther and uses content hashes to hash the files, and it also helps with parallel editing because files are blocked until they're read at the moment that they're edited. So basically imagine a subagent or multiple subagents trying to edit the same file. They'll actually get blocked by the Atomic harness because it'll tell them the file was recently mutated and you need to reread it to gain context of what the file was. So if there are multiple subagents working on editing a file, they'll actually get blocked. So we could actually do something here where I'll just show you how that looks like. Create a new test.txt, or let's just do voice mode. Create a new text and edit the file once you created it. And then also I want to demo multiple subagents trying to edit the same file. So try to edit the file and notice that the hashline edit should block you from editing that. So this edit tool is using the hashline edit algorithm under the hood. And then I asked it, can you can you have parallel subagents try to write to those files? And if you actually read into the traces, you should see that there'll be tool call errors because it tries to edit the file. And what this allows you to do is essentially have more assurance in parallel editing across agents. Typically, I will isolate things at a worktree level for different features, but this is even at a local level that this becomes a problem. So you see how it says edit rejected? This is the harness coming into play where it's blocking a file edit if the model hasn't reread the changes to that file. And this is an incredible token efficiency gain because the harness is actually protecting the model from hallucinating and editing a file. So this is a like just one detail of Atomic that helps improve the performance. And then so that's I just wanted to share that because that's one of my favorite examples to show.
That's so cool. Yeah, it's also, I think someone was also asking about on iOS devices, people were talking about how do I get it from my phone? You can use, I think we were saying earlier, Terminus or something, Termius and
Yeah, you can use
SSH.
Termius, and then I use Tailscale for my personal devices, so you
Mhm.
can create a tailnet. Yeah, if you want, we could make that like a follow-up discussion, but
Yeah.
essentially, like you can set up a private network and then have all of your machines use that private network and connect to a VPN, and you can remotely code. But open to if anyone wants to contribute those sorts of features.
Somebody also asked
We
about Buzz, because the Buzz integration, maybe having it chat back into Buzz and give an update and interact with it from there. I would think so, right? Or you can make a plugin or something with
Yeah, you
further.
can definitely make
Yeah.
plugins and use it there as well. I
Yeah.
think the idea is like this runtime is flexible enough to be plugged in everywhere. So you can build applications using Atomic as your runtime. That's another thing. So instead of using the APIs, you can plug in Atomic as the executable for your business logic.
Wait,
So that's another thing. Yeah.
there are certain business logics that can be defined in a workflow. Maybe like a call center,
Mhm.
right? They have documents, they have procedures, they have different things. And for someone to usually map out like a voice like call center, they would have to like manually create these nodes for things. And if a
Mhm.
call path didn't go down that, the customer would sort of be in this really weird loop. You
Yeah.
can throw some
You can imagine
intelligence.
doing.
Oh my God. And so this
Yeah,
thing
so
can
it's
be
not
doing
just
its.
Yeah, so this is not just a tool at for like directly working with a system, but you can plug it into your other systems as well and actually ship that in production.
This is crazy. Yeah, I don't think people understand like what is actually going on here. Beyond the masterclass, like there's a whole like runtime thing that this is how important it is to the core of where I think agentic engineer is going in the next half of 2026. Like
Yeah, definitely.
it's just insane. This is going to be the brains of your operations, and you need to have these things be able to make these types of decisions, work for themselves, generate loops, generate things that verify pretty much on their own because they should be smart enough to do this. And so having to do
Mhm.
that by hand is a pain in the butt. And yeah, there's a lot there that for it to kind of really just fly. This is and it's open source. Nuts,
So the
nuts.
idea is, yeah, I think people have been treating this graph engineering idea as things to accelerate their own workflows, but I don't think they realize that they can actually plug it into their existing applications as well as a runtime layer. So like your SaaS startup or things like that.
Wow, wow. Yeah, because
So
I have an
that's how it
OpenClaw that
yeah.
runs certain things, but the bummer about that is that like it got me to a point where things can kind of work and have a chat experience, but I have too many skills, I have too many this, like verifying that the work has been done correctly is like the biggest bottleneck, you know. Wow.
Yeah. One quick question: is part of my screen being truncated? Because it looks
Oh,
like it is.
at the bottom maybe? Let's see.
Yeah. Okay.
Um,
I'm gonna try to.
Let me just fix the aspect ratio here. I'll just do classic.
Yeah, I just want to make sure that
Is this
content
it?
isn't cut off. Oh yeah, that's perfect.
Okay, cool.
Okay, maybe I can make it bigger too. Okay, I think.
Yeah, you're fine. Yeah. I think I just
Yeah,
have
so the
to.
next thing I wanted to show is the ask user question tool. So how do you get human input? This is very basic functionality in a harness, and Atomic takes it to the next level for workflows. I'll show you can do human in the loop with workflows as well. But it's like there's a basic interface, and you get visualizations of what the model is trying to approach a problem with. So it's like a much more immersive experience, and it allows you to answer questions, and then be able to submit these. So that's some also very basic functionality as part of the harness. And then the next thing is Atomic comes with a to-do tool. So it can manage tasks by creating plans, and then it can use that to manage its work. This is like at the harness level, where creating a plan helps. And Ray, you were mentioning that I think you were talking about how Factory has that like to persist across compaction rounds. So you can reference to-dos across long-running tasks. So this is like another benefit where if you have multiple compaction cycles, the model can cross-reference the work that it did across previous compaction cycles, almost like a working memory. But
Wow.
that's the to-do tool in action. And then there's also so the first phase I should have mentioned is like the is the basic uh, kind of idea of tool sessions. And then the next thing I wanted to show is this idea of branching sessions. And we're not even talking about workflows yet. So this is going to get wild very fast. So there's the idea of tree navigation to switch branches. So you can go through. This is all inherited by Pi. By the way, they have like a really good base system, but it isn't as extensible as I would have liked, which is why Atomic is a fork of Pi. And then you can go back in the conversation history, and then there's fork where you can fork your context window. But I was mentioning earlier in our conversation that I prefer intercom because the model can dynamically fork context or like only give information instead of copying the entire context window, which could be wasteful. And then if you want to do debugging, there's also a clone session. So if you want to duplicate a session, but those are all, I think, tip of the iceberg, very basic things that every harness has. And then there's also verbatim compaction. So I won't show compaction here since there's not really anything to compact, but there's a /compact command, and there is also auto compaction. So you don't have to. So this verbatim compaction that I was talking to you guys about earlier, where it's the only harness that has verbatim compaction, and most harnesses have summary compaction, where they'll just generate lossy summaries. But what verbatim compaction does is it selectively removes context by asking the model what information verbatim is required to solve this current task. So it almost like uses a inspired by like the attention mechanism where you have a query and a key. You can match a query against the relevant context and then only keep the relevant context to the current objective. So it's a more it's a lossless compression compared to generating summaries. But that you can manually compact with compact, and then auto compaction also applies once you reach a certain threshold. There are also enhancements made to auto compaction. There are a few bugs in compaction in Pi for edge cases. Atomic does like conservative compaction in the sense that if a tool call will overflow, it does the calculation automatically for you. So you can avoid for these long running sessions running into compaction issues, which is a big deal because if you have a session that's running for multiple hours, it needs to be highly reliable. You need to consider all edge cases, and context compaction is one of those. You don't want the model to diverge and lose context. So the other cool thing in Atomic, one of the problems with compaction is the model loses track of what's important. I'm not sure if you guys have noticed, like when you have 7 or 8 compaction cycles, the model just forgets crucial information. So there's this really cool feature that Compaction also has. It's called the keep context tags. So if you as the user want critical information to keep in the context window, you can denote them. Run all test cases before saying you are finished. This is just a dummy example, but if you do something like this and then you create these keep context tags, Atomic will know in the next compaction cycle that no matter what happens, it needs to deterministically keep that context, unless it's like at some threshold where it definitely needs to remove other context. So what happens is you have 10 compaction cycles down the line, and the model still remembers exactly the critical feedback that you gave it, which is a big unlock in my opinion. So that's another sleeper feature that I recommend checking out. Also, the model can automatically decide whether some context is important to it and generate those tags for you by itself, if you want. This applies to workflows and the main chat. So that's another feature I think people miss. And the next thing I would, so compaction is configurable, so you can change whether auto compaction runs, how many tokens are in the reserve. You can control the compression ratio. So compression ratio tells you what's the fraction of the transcript to keep. So it's a number between 0 and 1. And so if it's 30%, you keep 30% of the conversation. So you can actually customize it. By default, it's 50%, since that works quite well. And then there's also another feature that will maintain the end most recent messages, just for additional coherency. And that's also configurable. Everything is configurable, even the query used for compaction. So if you wanted, you can use /compact, and this query, so whatever query you say, like let's say that you as the engineer can also manually compact and say /compact, and then test case was failing, or like a better query, and the model considers that query when removing lines. So if something is important to you in the next compaction cycle, you can directly encode this information. And these are all configurable. If you ask Atomic, it'll do all this for you. So you don't have to remember this all. Just ask Atomic. Even if you want, ask it to transcribe this video. And
yeah. I think a lot of people will be doing that. Another question that someone has here is like, how do you make sure the system rules are always enforced or wrapped around execution? So like my principal rules are loaded for each session and sometimes seldomly respected. People have had that issue with Claude usually.
Yeah, this is the superpower with workflows, because you can tell Atomic to enforce those rules in the workflow you build. So that directly will create deterministic calls or reviewers that will allow you to enforce those conditions. And this is what I'm saying about more advanced users will eventually find that they're creating workflows for their specific code base rather than using the built-in workflows with Atomic. But Atomic will provide them the primitives to do that.
I see.
So it's a much more reliable way to constrain the model to the practices that you want, rather than just prompting it and hoping for the best.
So in essence, people who have really big skill files, you may start to migrate to this new runtime where in essence, you're like extracting those things, especially if they're procedural, and then just telling Atomic like, hey, can you review these skill files? This is my workflow explaining a little bit what you do. And then it will start to then apply its knowledge to itself because it has all the knowledge about what it should be doing to make that very reliable for you, which makes a lot of sense because then you're spending less time, writing all these special rules and special cases for things. Oh, this is so crazy. This is crazy because I've made GitHub repos for workflows for things just to codify, like, this is what I do when I start, script writing. This is what I'm doing for weight loss. This is
yeah, for sure.
That's so funny. Wow.
So you can codify those things. And you can also export sessions, right? This is just basic functionality. You can save the transcripts. You can also tell Atomic to read your historical transcripts and do some cool things with those.
Mm-hmm.
But that's some basic functionality. You can also share sessions using a /share command, and this will share a GitHub gist. And you can also change the name of a session with a /name command. So now the session is called demo. And let's get into the more cool stuff. Let's actually build some extensions now. So Atomic inherits Pi's extension API, but it also extends it. So you can create a custom extension. So let's create one right now. I think this is useful because I don't think there's like a masterclass in even how to use the basic necessities in Pi. So this, since Atomic expands Pi significantly, I think it helps to just have this visual picture. So I have this prompt that mentions to create a Pi extension, and Atomic has access to its own documentation, so extensions can have workflows in them as well. But in this case, it's creating a greeter extension, and basically every time it registers a tool called greet, and then it can use that tool to say hello via a UI message. So let me restart this session so that we can see it apply. And then I'm going to say list your tools. And notice how there's a greeter tool as well. So it's super easy to add custom tools. Use your greet tool. Tony Stark is my OpenClaw instance name, in case that might be confusing. Yeah, very basic example, but I figured I'd include it here.
Yeah.
And then there's also a way to reload extensions without closing things. So you can use /reload, and then notice how it added this custom extension, and then you can reload these things without exiting the CLI. And then there's a /hello command as well that it added.
So somebody asks an interesting point here, is that will this actually, first of all, they're saying like thank you because it's actually solving a lot of their problems. But is this also planning to have like a GUI sometime in the future or for the app, or just going to be CLI driven?
I'm actually not sure. Yeah, that's something that's an interesting like consideration for the future of these human interfaces. But right now it's mostly a TUI experience. But if there are like community contributions or additions, like I encourage people to explore like different ways to represent it, because this is just a runtime and you can encode that information anywhere. I just made that design decision to keep everything with TUI, but that doesn't mean you have to.
Interesting. Yeah, because that's kind of what I'm thinking. I think there's certain things for me on mobile that I would love to just have. And so now I could just think about UI in terms of my own intents. And then like this can work as a runtime underneath, and it'll just feed in different views for data that I want to see, because this is always running, right? Like you're saying. And in essence, like, oh, wow, that's so cool. So yeah. Level 1 is like make sure that this works as like its own standalone thing, and then the next level is that people want to build, since it's an open source community driven thing. You can build your own views or take it and do something really cool with it, and definitely share it back.
Yeah, for sure. And boring things like you can use the skills that are built into Atomic or define your own skills. I'll skip intercom for now, but there's an intercom skill, and I think this will hopefully kind of blow your minds on what's possible. But we'll get to that. Just foreshadowing here. So you can run skills, and then once you invoke skills, here, why don't we just invoke one of the skills? Let's see. You can say improve. This is one of my favorite skills. Improve this prompt, and then say fix. So we're very lazy as engineers. So how can I optimize the prompt? Fix the tests.
Love it.
Yeah.
Make no mistakes. It's like that's all it adds to it.
Please do not make mistakes.
Yeah. Order me a pizza, make no mistakes.
So it uses the actual criteria for Opus 5 and then transforms it into like the recommendations that Anthropic has in their prompting guides. So it transforms
Oh,
fix this test to you're a software engineer working this repo, make sure the failing tests in this pass. This is like an incredible accelerator. Like imagine, and then Atomic does this as well, defines success criteria constraints. These are all things you can just do now, like without much effort.
whoa. Okay, so that's quite cool. And I would have to copy and paste from the cookbook. And it's just now sort of so do I even have to invoke the
Well,
skill,
not
or
even
can I could
copy and
just tell
paste.
it to fix my prompt and it would then invoke the skill automatically?
Yep, you can tell it to fix your prompt exactly, and we'll
Oh,
invoke it.
wow. So I don't have to
Yeah.
remember the slash command. I could just say fix my prompt, here's my, and then the quotes, and then letting
Yeah.
That's amazing, man. That's so cool. Yeah.
Yeah, and typically, it wouldn't even be copy paste. Sometimes you need to interpret like what the guidance is, and it just makes the process, yeah, much much more painless.
Yeah. Wait, roll that back again. So with the skills, what somebody was saying, so like you can do slash command to invoke the skills, and you're showing an example of improving a prompt. And so our prompts can be so vague that sometimes someone says like, you're a senior dev, make no mistakes. And then like you send it off. It may not be the best prompt specifically for Opus 5 or something like that. So what Alex
Mhm.
has done is, depending on the model that you have loaded, he has all the prompt guides that are built in. So
Yeah.
instead of even doing slash skill, you can just say improve my prompt, put your prompt into the quotation marks. It will invoke that skill automatically and then restructure the actual prompt to, right, as you see right here, the improved prompt, which defines the role, the goal, constraints. And typically, if you, no one's going to write prompts like that by hand because come on. Like, but if you have
Yeah.
these agentic engineering workflows, and the agents themselves can now reference the guides with the skill files to do that automatically. But just think about this for a second. Think about where we're going to be like at the end of this year when the agents have these basically, um, how would you call these? I guess primitives in some way, right? Like these
Yeah, I
tools,
call
these
them primitives,
pieces.
yeah.
Yeah. To take these things and start to run with them automatically. So it's the difference between like if you have a home with like stuff that's really empty versus like you have a warehouse that has tooling and like robotics and everything else. You're going to be able to produce way more economic output in that warehouse for many things because you have different tooling for all kinds of stuff, whether it's specialized tooling or in food manufacturing, whatever you're doing, you're putting together these types of things. So I want you to think about that for a second in terms of like what AI agents are doing in terms of software factories and this bigger concept of using agents to drive results. So as engineers, as people who want to have high quality production software, you're going to need a lot of this tooling in place. You're going to need a lot of these primitives, which are skills files, tools, workflows. How can agents operate autonomously and grab the right things reliably, repeatedly for things that we know that don't need tokens? They just need a script to be executed, or a path that goes down a certain thing that's not going to fill context windows. And that's part of the bigger thing, which is what we are now labeling like the agentic runtime. So when things are
Mhm.
actually running and loaded in memory and executing on things, the context window is the most precious thing. And the agents like Claude Code, Codex, and so forth have ways to manage that context window that they do. And they're right now, for me, it feels like I'm sipping my intelligence through a tiny straw. And I know that there's a lot more intelligence because those are really big models that can do really cool stuff. So when you kind of rip that out a little bit and you put those models in a like runtime environment with this type of tooling that Alex has built with Atomic, now they're able to feel smarter. They actually can verify results. Wait, I thought Opus was sloppy. No, it's not. When you combine it in this runtime, it's freaking amazing. If I thought GPT-5 was sloppy too, it can be if you're using a different harness. But if you then take away that straw, if you put this in this runtime, if it's able to discover these tools that it has for itself to improve its prompts, to do these types of tasks, add verifiers, spin off nodes. Oh, I discovered that I'm in this work tree and this is kind of how I'm operating. You have all these procedures already lined up for me. I'm just going to follow those because those are already there. you're giving the agents the best opportunities they possibly have, right? It's like putting your kid into like the best university because the environment that it's in helps it succeed. If you're planting plants, you're going to put them in the best environment. You're not going to plant them in the desert because that's not going to help it grow. A tropical plant is going to want to be in a tropical environment. So you're, in essence, putting your agents in those environments that's going to help it thrive. And that's kind of the goal here. And we're just scratching at the surface. What's crazy, especially if you have done any type of engineering or think this way, is that yes, you can keep stacking these things. And yes, the system itself can improve itself. And that's the whole point. Like, this is kind of why I'm having this like crazy moment where I literally on X, I posted it. And when we were going through this, it's like, I think I finally cracked it. There's a better way to run these agents without the slop. And you see what Atomic is doing, how it splits out, actually using, this is not just kind of like, I'm just going to choose these random models for whatever reason. There's actually a whole logic behind it. We've been covering over the last 2 hours, like kind of breaking it down for you. And, this is just the beginnings of this. We're just scratching the surface for the masterclass, but we don't want to get you too confused because there's just a lot to take in at these different levels. And, Alex is trying to build this community of people where we can kind of share, what does this really mean for us, right? So like, I don't know about graphs, but it actually created some stuff for me based off of my interactions within my existing repo. And so the agents will take these primitives that it has available to build the graphs, builds the reviewers, and then it will, use that Pareto efficiency that we talked about earlier that was measured from these different models, and it's doing its own measurements too, to analyze what's the best cost and performance. We don't want to just burn tokens for the sake of burning tokens. We're being extremely intentful about it. This is an engineering process. There's control flow. There's a lot of different things that are just kind of tying together here, that this is kind of why I feel like this is such an important live stream, such an important thing to get out here. I will have chapters after the live stream like planned out so you can go back to these different segments. But I also have an edited version as well, kind of bringing it down, taking out some of the breaks and stuff and just kind of really focusing on some of these core pieces. Because once you understand how these things work, it's not that complicated afterwards to then start to, bring your business experience in, bring your procedures experience in. And like he said earlier, this can be the brains for how your apps can work at the higher level. So now you as a person who's operating in this world can start focusing on what's the product experience with my customers? What's going to bring me the highest value? I run a call center, and then these are the biggest pain points we have. We're spending a lot of time like writing workflows by hand. Can we put this type of system on it and it can automatically take a lot of the information and stuff we have documented and work in this new agentic environment so that it can help us achieve our goals better, help, drive certain metrics or certain things better. So you want to start thinking in these types of ways, and it's going to really change the way that you operate with agents. So you're not just running a cloud code instance with 50 million skill files all customized to like one workflow that'll break tomorrow when the new model comes out, right?
Right.
This is why it's really important. This is why I'm like so passionate about this, because like this is happening in real time. And a lot of people are confused for the right reasons because it's so like everywhere. And I don't think anyone's really kind of combined it together like the way Alex has done with Atomic. There's some other folks who've been contributing, I think, to the repo as well. And this type of concept. And it's not only us that are using it. There's people at big FANG companies that are using this on production software to try to get this stuff running. So it's not like it's just like, oh, here's like some random kiddie side project. It's pretty well evolved and continuing to evolve as well, right? Yeah.
Right. Yeah.
Yeah, man.
So I like to joke that, Atomic uses Atomic to build itself. So I reached a point where the system can build itself, which is, I think, the most satisfying part.
Exactly, man. Yeah, man. Let's kind of like I think what we can do is probably do a part 2 coming up, where like, because I'm going to be coding all weekend and stuff, and I'll definitely have this up, and folks, you can just drop in. I will be doing some coding sessions with this live on the weekend, so just pull on up. I'm going to be tomorrow at the Factory AI event, and so folks can kind of reach me there, and we're going to be chatting about open models and a bunch of other cool stuff. But like all weekend, I'm going to be building, so I'll go live. We'll be answering questions. I think I'm not signing up Alex for this, but I know I will be using this live. I'll have more questions and I'll probably queue them up, and then I'll figure out how I can coordinate with Alex to maybe do a session. Probably I'll do it on my community. If you haven't had a chance to, I think I have a school community that's free. So you can sign up there. It's free. And then you can just, I'll probably gather some resources here. So it's school.com/start-my AI. And in here, you can just join the group, and then I'll schedule something on the calendar. So that way you'll be able to see it when it's coming up. And I'll figure out a day that would work for Alex and folks so that we can just kind of do a group session for free and just kind of start chatting about this, because I think this is the most important thing that is going to be evolving in 2026 that not a lot of people are talking about yet per se. And it still feels nascent in terms of like all the information that's out there and sort of confusing. So I want to like deconfuse that down. And this is part of the reason where we're doing this. So definitely check that out. I think this is going to be a really cool thing to explore and take a look further if y'all have any questions. So yeah, I mean, thank you so much for your time, man. You've given us so much information that like,
Yeah, of course.
I mean, people are going to be spending so much. I have to go back and digest some of the stuff, and just my mind's going crazy because you've only given me a small sample.
Yeah, we haven't even gone to the actual workflow engine yet. I was just explaining what are the primitives that then build into the workflow engine. So like there's a runtime in a runtime in a sense.
Yeah, it goes really deep. And I think what's going to be cool is like in the next day or two, I'm definitely going to be playing around live. And then what we'll do is we'll come back, and then I'll like kick off some more projects, and we'll kind of go a little bit deeper. Also, I want to have some time for the folks who couldn't make the live stream for you to actually ask some questions and drop them in the comments. So that'll be good for us for like the part 2 in terms of like, you tried it out, this didn't work, or what can we do, or what can I find out some more information? Because I had a lot of questions when I started using it too and started implementing it. So I mean, for you to check it out, all they have to go is to the GitHub repo, github.com/bastani-inc/atomic, and that'll be probably the fastest way that you can check out the repo. And so to get started in the repo, like you said a little bit earlier, if you're just kind of tuning in right now, or bastani.ai is the other place here. We'll probably take you here actually. And it's just like a one-line command. So bun, add, whatever. And you're pretty much ready to go after that. Once you start the repo, you just log in, and then you select your providers from XAI, Claude, GitHub, and so forth. And so you may be wondering, you'll see a warning about Anthropic and whatever. I'm personally using my $200 a month pro plan, and it's just using my subscription, and I'm not doing anything crazy with it, and I'm not even close to hitting my limits, which is really, really nice. In ways, I think it'll save you a lot of tokens, especially if you have 2 different plans, like the GPT plan and the Claude one, because I have a $200 a month pro plan. So you don't get charged extra usage. You just uses your subscription right out the gate. So that's super handy. And I think if you're considering that and you're like, oh, should I use it or should I not? That's kind of where, just kind of give you a heads up. That may change in the future, but you'll see this warning, and that's kind of where you're at. Other than that, just start prompting away, and it should start kind of helping you with whatever you want to do. And you can see some of the techniques that we were talking about earlier and just start applying them. And you'll see me kind of coding with them in person. So supports a lot of really cool stuff. Definitely really, really cool. Yeah.
Yeah, and then one more thing I wanted to say is there's a Discord community for Atomic. So if you have any questions related to that. And then the other thing I would say is if you start to use it and really like it, would really appreciate you to kind of share your workflows. And if you at me, happy to repost what you have. And we can build a community of these workflows and best engineering practices. And the other thing is love to grow the community. So if Atomic works well for you, I'd love to get a star and be able to scale the repo further and get more contributors, because that helps with kind of maintainability of the repo and things related to that.
Exactly. Yeah. By the end of the stream, we got to see at least 500 stars. Take it to 1,000 tonight, folks. Do your magic. Have your agents tell your agents so your other agents can start too. So, oh my gosh. Yeah. I mean, there's so much to unpack here, which is really cool. And I've learned so much just about agentic engineering to just kind of begin with. It's dispelled some of the myths, especially like around graphs and like how do you run them? And I think that was the bigger part. It's like, do I have to spend a lot of time coding my own graphs and then executing them, maintaining them? Because I just, to be honest, had so many war like scars that started to really trip me back up again. It's like, oh man, QA engineering days, like, oh,
Yeah.
my graphs maintain my graphs for the graphs that I have to maintain with another agent that maintains graphs, so that other agent has to verify those graphs to maintain the graphs that are being maintained. So
Yeah. It's a lot.
yeah, so the now it's just like, oh no, this is actually built as part of this runtime. So if you, anything you take away from this whole thing, agentic runtimes are here for 2026. It's probably going to be your favorite keyword of 2026, agentic runtime. This is something that was whispered about earlier this year from the folks in Korea who flipped Claude code in 2 hours into Python on a plane and then have rewrote that into Rust. Using these techniques, using agentic engineering techniques, this is an extremely evolved version here. Very approachable, extremely easy to install. Bring your own subscriptions. It's not tied to one specific coding provider. And it cooks. Absolutely cooks. Extremely extensible. Has so many primitives that are built in and ready for you to just take out the door. Open source, free. We're not trying to sell you anything. We're just trying to meet other great engineers who are as passionate about this. And even if you're not an engineer, if you come from a different background and you're trying to get into this, it's going to really help you with your quality of software, and then having those discussions with your engineering friends. So then once they become aware of like, wait, there's already a system for this. And you're like, yeah, bro, like where have you been, man? You've been asleep. You can put them on the next level and they're going to just thank you so much for like all, being brought into this whole new realm of what the future is of agentic engineering without like vague posting and saying like, or not even giving as much information, because it's really specific to different repos. But I feel like this is a phenomenal breakdown. Alex Lavaee used to work at Microsoft, or works at Microsoft, and used to work at Boeing, used to work at like crazy background again, with different, 3D modeling, 4D modeling, a crazy cracked background. And my guy is like not a junior engineer, even though like on paper he is. Has experience of so many years and like shipping software, helping people who ship software at these large scale things. So this is a perfect thing that I'm trying to use for my own coding, because I want my coding quality to be really high, my output to be really high. And I'm just thankful that you've taken the time to help us here, and excited for part 2. Definitely join the community if you haven't had a chance to check out, Alex and those folks. Any other last words that you want to share with the audience?
I guess one thing I would add is I think what Atomic is trying to do is be the first in the category of verifiable coding agent runtimes. So when you're building high assurance systems, or you want to get reproducible results with coding agents. So more than just extending the runtime idea, it's this idea of verifiability. And that's something that I want people to take on and understand how they can have uh, high confidence in the systems that they ship, and not just rely on the model uh, telling them so. Always question the status quo, essentially.
That's awesome. Verifiability. That's going to be the moat. You know what I mean? So it's like, it's really interesting that we're here in this new era of AI agents constantly evolving. I wouldn't let all of that evolution scare you. We're here to break it down. First principles, start from the basics. We're going back to computer science basics, control flow. Can you control that? It should definitely be possible. Get some reliability here, and I'm really excited about the future of these things. So stay tuned. I'll have some more live streaming coming up in the next days, where I'm streaming live. I'll be using this as well to do some of the work that I'm doing, and there's a bunch of folks who are going to be joining in the community. And yeah, so I think another person had some questions here. It says, does Pi extensions work with Atomic?
Yes, everything in Pi is backwards compatible. It's just Atomic comes with more primitives, and it significantly extends Pi. So you can easily install Atomic and inherit your custom extensions.
That's amazing.
One,
Yeah,
yeah.
thank
One
you
thing
so
I
much
would say
also.
though is,
Hmm?
oh yeah, for sure. Just one quick thing, like if you have Pi subagents or Pi web access installed, I would recommend removing those, since Atomic already has those installed and just ignores those configs. And the sub agents are more powerful than like the baseline systems.
That's amazing. Hey man, we already have 405 stars now. That's really, really cool. So yeah, congratulations on like, first of all, finding me at the AI engineer event, tracking me down and just kind of, saying hello. And I, to be honest, wasn't really expecting the level of detail and in-depth that this project had. And really until I sat down with you. And then, earlier this week, I was like, oh, this changes everything. This is, I know it sounds like AI hype, but it's not, trust me. But don't trust me, bro. I want you to go install it, go play around with it, and let me know, because I think
Yeah, actually tested. Yeah, definitely.
Yeah, there's no trust me, bro energy here. So like, yeah, this is what we do. Ray Fernando. I used to be an engineer at Apple. I've worked there for over 12 plus years. People are using stuff that, it's like in the hands of billions of people now, which is amazing. And I, deeply passionate about making products, and I'm in this new era where I'm able to do what I want, talk to you, play around with these agentic tools, find people who are like literally gold in the middle of nowhere, right? And my guy had 9 followers on X before my post. Do you think anyone's gonna like find this in the middle of X? Like, no, like, it's just, this is what we do. Like, once you find those people who have the sauce, I want to be around them. I want to be around you. I want to be around you. The fact that you're watching this, you care about making your engineering systems the cream of the crop. And, we're not here to sell you anything. We're here to just bring people together to share that joy, and then continue to share that passion beyond what we can even imagine. So if you enjoyed this, definitely hit that like, because it's going to share with other people who are very similar to you or your friends. Share it out to other folks. Share it within your communities. Tell them like, what you're checking out, and share the live stream. I will have definitely clips and all that stuff all set up for you. So come on back later this week, and hit the subscribe and so forth, and you'll get a notification when the video gets published, when I get this all edited down. So I'll have some clips as well for the folks to go ahead and do that. So Alex, man, the part 2 is definitely coming. Drop those questions in the comments.
We just scratched the surface of the demo. We didn't even get to the end of like the main chat experience, let alone the workflow engine, and lots of advanced usage coming up.
Yeah. And maybe I can like next stream kind of start out like with something I have in progress a little bit, like I was showing earlier, and you'll see. And then we can kind of like start branching out and talking some of these other things. But yeah, as part of a masterclass, you'll have these videos, and I think they're going to be a really good resource for people who are on YouTube looking for a little bit longer. And no one, like I said, no one's on YouTube talking about this. I mean, very few people are going in this level of detail, but also sharing the source code and also giving you the agentic primitives so that you can talk with them and say, tell me more about the intercom thing. Tell me more about what you're doing with context windows. Tell me more about what you're doing with compaction. It can answer it because it has all of that there. I'm telling you, right. This is crazy. Yeah, so I'm going to get some lunch, and appreciate the time. Big thumbs up to everyone who's watching. If you're watching this right now, if you're watching this maybe back as a video on demand, and you made it this far, nobody really makes it to the very ends of a live stream from beginning to end, drop that comment. Let me know that you've made it this far, it's like to the very end, because like that means you're really paying attention to what's going on and kind of in this whole world. And we definitely appreciate you because you're a mega fan. And from the bottom of my heart, excited for part 2. Let me know what questions you have. We're going to have to get Alex back on because you probably get back to work too, right? I just stole you away from like 3 hours of work, right?
Yeah, I had background tasks running, so
let's go. That's what's up, man. Yeah, that's the whole goal for me, to be in Hawaii, where like I'm paddling, I'm on the beach, and my agents are doing the work and verifying themselves. So I come back and I'm like, you know what? This taste is not good. It's like I'm just a chef. I'm like, nah, come back. Let's go. Okay, yeah. There are some MVPs of the stream. I want to give a big shout out to Nikolai, who basically watched this thing from start to beginning. Holy smokes. Were you anyone else here from the beginning who watched this whole stream? You guys are the real MVPs right now. That's absolute bonkers, man. Yeah. Maria says like she wants to see the intercom thing. Yeah, you gotta get the repo installed. I think you'll have some fun, and then but I think part 2 will definitely do that. Oh, also on Twitch as well. I forgot, like on for the Twitch audience, it was awesome. Thank you so much for tuning in at Abby Night as well. Let's go. Nor Lava, let's go. What's going on? You've been here since the very beginning too. Not only on here, but you're also been on X as well. Super awesome for boosting the numbers here. Definitely appreciate that. So yeah, also I appreciate everyone who's been starring the repos. That's been super helpful because that helps them get some more support and so forth like that. So yeah, have not been forgetting about those Twitch users because y'all have been doing this pretty. Also, Garant Hood, you've been in here for quite some time as well with some good questions. And I think it's been kind of fun to interact with some of those folks. So as of now, the star count for the repo is it was 405 last I checked, just refreshed again, it's 408. Make sure you star the repo, get that stuff going. Follow Alex. Let's see, I think on your X account, let me just go ahead and show some people so that they can know which account to follow here. So it's x.com /, what's your handle?
Alex, and then my last name, Lavaee.
Cool. Here we go.
Very
awesome.
Basic.
141 follow. Let's go. It's like the fastest climb from like 9 followers to 141. Let's go. So yeah, we are cooking live. Definitely give him a follow. He's going to be posting some really cool stuff, and like more to come. So awesome, folks. Super excited about this build. And yeah, we'll come back to you more with part 2. And I'm just super excited. I love live streaming. I'm so glad to be here back in the Bay Area with all my equipment again, and keep these nice quality streams alive for everyone else. So make sure you subscribe, like, and we'll see you guys in part 2, y'all. Peace out.
See you guys.